Hi viewers, welcome to my channel. Today I will make you learn how to solve DBMS MCQ questions for InfyTQ Certification Examination. So not only for InfyTQ Certification Examination, you can solve any kind of MCQ questions in the upcoming MNC company related examinations.
So here consider the relation. Here the relation name is salesman. Within the relation, three attributes are there. One is sales ID, second one is sales name, and next one is location. Here the schema of the entire table or the relation is SID, SName, location. This is the schema of the table. And coming to the instance of the table, within this table we have four rows are there. The first row is 1 Peter London, and second row is with respect to the second row the salesman details, 2 is the SID, Michael is the salesman name, and Paris is the location. Like that we have four rows are there. So we can call all these four rows are the instance of the table. Now what is the cardinality of the above relation? Here we need to know what do you mean by the cardinality. Cardinality in the sense it defines the number of instances of an entity associated with the number of instances of another entity. But here we have only one entity. Within that entity we have to identify how many number of instances are there, how many number of rows are there. 1 2 3 4. Within this entity or the relation total number of rows are 4, so that the cardinality of the above relation is 4. So here out of all the four options the right option is C. And here the cardinality, for the cardinality we have another definition is there. We can simply call the number of distinct values in a table column which are related to the number of rows in a table. The number of distinct values in a table column. If you are going to consider one column, SID is one column. Within that, the number of distinct values, all are distinct values only. 1, 2, 3, 4. So total number of rows in this relation are 4. So that the cardinality of this above relation is 4. This is the right option. Now coming to the next question, consider the relation salesman. Here also salesman has three attributes: SID, SName, location. Now what is the degree of the above relation? Here we need to know what do you mean by the degree. Degree in the sense the number of attributes or the columns in a relation or table. Here the number of columns that are available in this table are 3. 1, 2, 3. First column name is SID, second column name is SName, and third column name is location. So that here the degree of the above relation is 3. Out of all the four options, the right option is first option. Coming to the cardinality, the number of tuples or the rows present in a table. Here 4 rows are there, so the cardinality of the relation is 4. Very simple. Now coming to the next question, which of the following statements is or false about the primary key? We need to identify the false statements about the primary key. Now the first statement itself is primary key uniquely identify a row. Exactly correct. With the help of primary key, we can uniquely identify a particular row in a relation. It is a right statement. Now coming to the next statement, there can be more than one primary key for a table. No, it is not at all correct. For each and every table, only we should have one primary key. We should not have more than one primary key. Here this statement is false. Now coming to the next statement, primary key columns in one table can be referenced by foreign key columns in another table. Exactly correct. So in the primary, for example, in one table primary key is there means which we can be referred by the foreign key columns in another table. So it is also right option. Now coming to the last option, columns with string like char or varchar2 data types cannot be made primary key because they are large. No, we can make the columns which are having the data type char or varchar2, we can make them as primary keys. There is no problem at all. Here the statement is not at all correct. Now out of all the four statements, the second statement as well as the fourth statement, these two are incorrect statements and the right statements are 1 and 2. Here as per the question we have to identify what are the false statements. The false statements are second statement and fourth statement. Very simple. Coming to the next question, we have two tables are there, recharge plan and recharge payment. Here the question is identify the candidate key for the recharge plan table. So for the recharge plan table we have to identify the candidate key. First of all we have to know what do you mean by the candidate key. Candidate key is a set of attributes that uniquely identify the tuples in a table. Now within the candidate key we can combine the multiple attributes so that we need to identify the unique tuples in the given table. Here none of the column is qualified under the primary key. Why? Because for each and every column some duplications are there. With respect to the operator column, here the duplications are 8tel is occurring 2 times as well as MTS is occurring 2 times. Within the plans also full time is occurring 2 times, top plan is occurring 2 times. In the amount also 150 is occurring 2 times, and as well as within the recharge type also special top up regular occurring multiple times. Now we have to identify the candidate key for the given table recharge plan. Now if you are going to take operator as a candidate key, operator attribute itself as a candidate key. With the help of operator we are unable to identify the unique tuples of the table. Tuple in the sense a single row in the table. So with the help of reliance if you are going to take, so here no problem, but Airtel it is occurring 2 times. That means we are unable to take this operator as a candidate key. With the help of operator there are some duplications are there, like Airtel is occurring 2 times, MTS is occurring 2 times. Next let me try to consider plans. With respect to the plans also we are unable to make it as a candidate key. Why? Because within the plans so some duplications are there, there is no unique values with respect to the plans column or plans attribute. Full time is occurring 2 times, top up plan is also occurring 2 times, so that we could not take operator and as well as plans as candidate keys. Now let me try to consider the next option. Within the next option, operator along with recharge type. Here two attributes we are going to consider them and we are trying to make the candidate key. Try to check it now. Operator and recharge type. If you are going to consider operator and recharge type, from this entire table for each and every row it should be unique with respect to the operator and recharge type. But here if you are going to consider MTS is the operator, and for the MTS the recharge type is regular, and we have another MTS is the another operator, for that also regular is the recharge type. That means we are unable to identify the unique tuple from this particular operator and recharge type combination. If you are going to make them as candidate key we are unable to identify the unique tuple. Here we are getting duplications. Now try to consider, that means third option is also not correct. Coming to the last option, with the help of operator attribute and plans attribute, try to check it now. With respect to the operator and plans, for the Reliance the plan is full time, for the Airtel the plan is full time, and as well as for Docomo the plan is top up, and again Airtel is coming but the plan is different. That means we are uniquely identifying the tuple. As well as for MTS the plan is, the first plan is top up plan, and once again for the same MTS operator we are getting another plan, 3G plan. That means here with the help of operator and plans, if you are going to make these two as candidate key, we can uniquely identify the tuple in a given relational table. So candidate key is a set of attributes that uniquely identify the tuple in a table. Here these two are the set of attributes. With the help of these two attributes we can make one candidate key so that we can uniquely identify the tuple in a given table. Candidate key is a super key with no repeated attributes. Yes, there is no repetition at all. The primary key should be selected from the candidate keys, but here none of the column is going to qualify for the primary key because each and every column, within the each and every column we have some duplications are there. So with the help of candidate key only we are going to identify the unique columns, unique rows. And coming to the next point with respect to the candidate keys, every table must have at least a single candidate key. Yes, we are having, and as well as a table can have multiple candidate keys but only a single primary key is available. Yes. So now out of all the four options, the right option is with the help of operator attribute and plans attribute we can uniquely identify the tuples in a table so that we can make these two as candidate key. So from this question the right answer is D option. Now coming to the next question, we have two tables are available, and the two tables are, one is recharge plan and second one is recharge payment. Now the question is identify the primary key for the recharge payment table. For this table we have to identify the primary key. If you are going to take the first attribute or the first column recharge ID, within that all the column related values are unique values only, so that it will be qualified under the primary key attribute. Definitely it will be eligible for the primary key attribute. Now we have to check the remaining attributes also. Now coming to the next attribute, operator. here within this column some duplications are there, no unique values are available, so it is not at all qualifying under primary key. In the plans also we are facing the same problem. Some duplications are there, no unique values are identifying with the help of plans column, as well as card type also. Within the card type also some duplications are there, there is no unique values. So here with respect to the first column itself only, we are going to get the unique row information. So here what do you mean by the primary key? Primary key is a column or group of columns in a table that uniquely identify every row in a table. With the help of this row ID, it is a unique ID. There is no duplication with respect to the remaining IDs. 1 is available here, 2 is available here, 3 is available here. All are unique IDs, so that with the help of that IDs you can get the unique row from each and every table. And here one more important point is a table can have only one primary key. So here out of all the attributes, the eligibility of the primary key is for recharge ID column. Now out of all the four options, we are going to observe operator will not qualify for the primary key, plans will not qualify the primary key, and as well as recharge ID, yes, it will be qualified by the primary key. So the right answer is C. And coming to the fourth option, if you are going to observe operator along with the plans, let us check operator along with the plans. So we can get the unique values, no problem at all. With the help of first operator we are getting Reliance and the plan is full talk time. And with respect to the second operator Airtel, our plan is full talk time. Here it is also unique value. With respect to this combination of two attributes operator and plans, we are going to retrieve the row uniquely, as well as within the last row also with the respect to operator Airtel, the plan is top up plan. There is no duplication set, all are unique only. But the problem is the combination of this operator and plan, these two keys, these two attributes are comes under the category of candidate key. So with the help of these two keys we can form one candidate key. So now here one more important point is a table can have only one primary key. Here already the primary key is available, and combination of operator and plans, these are comes under the candidate key. For example, there is no primary key in the sense the candidate key itself it will become a primary key. Why? Because primary key is a column or group of columns. With the help of group of columns also we can form the primary key, but fortunately within this table one special column is there. The column name is recharge ID. So with the help of this recharge ID we can get the unique rows. Due to that region we need to consider it as a primary key. Here operator and plans are comes under the category of candidate keys, so we need not to consider this option. Out of all the four options, the right option is C option. Now coming to the last question, here two tables are available, recharge plan as well as recharge payment. Two tables are available, and we have to identify the foreign key for the table recharge payment. We have to identify the foreign key for the recharge payment table. Before going to identify the foreign key, we have to know what do you mean by the primary key and as well as foreign key. A primary key is a column or group of columns in a table that uniquely identify every row in the table. So the column, within that column, that all the values should be unique, so that you can easily identify every row in a table. And for each and every table we have only one primary key. Now coming to the foreign key, a foreign key is a field or a column or a collection of fields in one table that refers to the primary key in another table. So foreign key is acting as like as a reference to the primary key in another table. Now here if you are going to observe within the recharge plan, if you are going to consider this is first table, within this recharge plan, unfortunately we are unable to make individual columns are primary keys. Why? Because if you are going to consider operator, we are unable to make it as a primary key. Within the operator we have some duplications are there. Airtel is occurring 2 times and as well as MTS is occurring 2 times. We could not make it as a primary key, and we are unable to identify any row. As well as for the plans also we are facing the same problem. Within the plans full time is occurring 2 times, top up plan is occurring 2 times. In the amount also 150 is occurring 2 times. Recharge type also, within the recharge type special recharge type is occurring 2 times, top up is occurring 2 times, as well as regular recharge type is occurring 2 times. So due to that reason, we could not consider individual column, any one of the column in this table, we could not consider it as a primary key. Now what we have to do, we need to take the combination of two keys, combination of two attributes, so that you can make it as a primary key. There is no problem. Why? Because as per the definition of the primary key, it is a column or a group of columns. With the help of group of columns also we can make the primary key. With the help of individual column we are unable to make the primary key in this table, but with the help of group of columns we can make the primary key. Now how it is possible? So let us try to consider operator is the first column and plants is the second column. With the help of operators and plants, with the group of these two columns, we can make the candidate key, and itself it is acting as a primary key for this entire recharge plan table. Try to check it now. With the help of these two columns, we can identify unique row in the table. Reliance full time. With that operator Reliance, full time plan is available. Airtel, with the help of Airtel, we have full time is available. With the help of Docomo operator, top up plan is available. With the help of Airtel is occurring one more time, but here the plan is top up, it is not at all full time. If it is also full time, means these two columns are also not comes under the candidate key as well as primary key. Please remember that point. As well as MTS, the first plan is top up plan, and again one more time we are getting MTS as a operator. For this, the second plan is 3G plan. So with the help of operator and plan, we can make the candidate key, and itself it is acting as a primary key for this entire table. Now if these two keys are combining to form a primary key in the sense, so the primary key in the table, the primary key in the particular table, it is acting as like as a foreign key in another table. Here in the another table, the question is identify the foreign key for the table recharge payment. Here within the recharge payment, we have that the both operator and plans are available. These two columns are acting as like as a foreign key, so that those are referring the primary key of the another table recharge plan. So here the right option is we have to combine operator and plans, so that we need to make it as a foreign key. It will referring the primary key of the recharge plan. Within the recharge plan, the primary key is the combination of operators and plans. Now out of all the four options, if you are going to observe, operator is not correct. Why? Because here duplication is there. Plans is not correct. Within the plans also, no unique element, no unique row. We are unable to identify the no unique row. And as well as recharge ID and operator. Recharge ID, there is no recharge ID column in the recharge plan table, so that we should not consider it. And coming to the last option, we can combine operator and plans in the recharge payment table, so that we can make it as a foreign key, which is referring the primary key of the recharge plan table. It is the right option. D is the right option among all the four options. What will be the output of the following command? Here we have one command is there. The command is create command. Create table, table name is employee. Within that we are taking three attributes. The first attribute name itself is name, employee name, and which is of the type of varchar2, and we are taking it as a primary key. And we have one more attribute is there. That attribute name is date of birth of the employee, and the data type of this attribute is date, and we are making again it as a primary key, but it is not possible in the table creation in database management system. Within the relation or table or the entity, you should have only one primary key, but we are trying to define two primary keys with respect to the two columns. It is not at all possible, so that you will get the error. Here out of all the four options, if you are going to observe, the third option is the right option. Error will be thrown. So in the first option, two primary keys will be created. It is not at all correct. For each and every relation of the table, only one primary key will be there. And coming to the next one is composite primary key will be created with name as first attribute. It is also not at all correct. Within the table we should have only one primary key. Here also the last statement is also wrong statement. Now out of all the four options, the right option is C. Coming to the next question, consider the creation of the following table. The table name itself is customer. Within the table, the attributes are customer ID, account number, customer name. With combination of columns customer ID and customer number should be unique. That means here customer ID as well as customer account number, with the help of the combination of the two columns, we can make them as primary key as well as candidate key, so that you can identify a particular table row uniquely. Now, which of the following options is correct? Now, the first option is put unique constraint on both the columns separately. We should not do like that. So, you have to provide unique constraint at a time. In the table level, we have to provide the unique constraint upon the both the column names, customer ID and as well as customer account number. Now, first option is wrong. Now, coming to the second option, this type of constraint is not possible. It is also wrong. Yes, it is possible. We can combine the two column or two attributes so that we can make it as a primary key, or we can call it as a candidate key. If within the table there is no primary key, means we can make the candidate keys as a primary key. There is no problem at all. And next question is, the next option is put primary key constraint on both the columns separately. No, we should not provide primary key constraint on the both the columns separately. Coming to the last option, put a table level unique constraint involving both the columns. Yes, it is the right option. We have to put the table level unique constraints. So within that we have to involve the both the columns, customer ID as well as account number. Out of all the four options, the right option is D option. Now coming to the next question, which one of the following DDL statement will create a table? Assume table customer is already created with appropriate constraints and data types. Already, let us assume that we have one table is there, the table name itself is customer, which is already existing. Now we have to take the syntax below. We have to create one new table so that out of all the options, which one is the right option? Here, within the first option, we are trying to create the table. The table name itself is account. Within the table, we have three attributes are there: account ID, account customer ID, as well as balance. And with respect to the each and every attribute, its respect to data type is available. Account ID is of the type of number, customer ID is of the type of number, as well as balance is of the type of number. And upon these attributes, we are applying constraints. So for that, we are using constraints separately, and this is the right syntax. If you want to apply the constraints upon the given columns of the table, means you have to write the constraints separately, and whatever the constraint that we are going to apply, whether primary key or foreign key, for that constraint we can assign some name reference also. Here for the primary key, we are assigning some naming reference. Here the naming reference is AC underscore AID underscore PK, and here account ID we are making it as a primary key, comma, from the customer we are taking customer ID as a foreign key, which is referring from the customer CID, so that we are making it as a constraint, and the reference name itself is AC underscore CID underscore FK. So there is no doubt at all, this is the right syntax. Everything is fine in this particular table creation. Now coming to the next option, within the B option, we are trying to create the table. Create table, table name is account. Within the table, we are trying to create multiple attributes. The first attribute is account ID, which is of the type of number. Here we are providing this account ID as a primary key, but here we need not to use this parameter in order to provide the primary key. If you want to make account ID primary, so we need to take it as a not null attribute, and we can make it as primary key directly without using a constraint keyword also. So there is no doubt at all. But here we are making account ID as a primary key, and that too without using the constraint keyword. If you want to make it, you should not provide it in the format of parameter. It is not at all correct syntax. Here this particular option is not at all correct as per the given question. So it is the wrong option. Now coming to the C option, create table, table name is account, and here account ID is there, and here with the help of constraint keyword we are trying to apply the constraint. But one thing you have to remember, if you want to use the constraint keyword in order to apply the constraints, you have to make it separately. You should not provide it while at the time of defining the attributes of the table. It is also not at all correct syntax. It is also wrong option. Now out of all the three options, the right option is A option. Now A is the right answer with respect to the given question.
Now coming to the next question, a relation is in 2NF, second normal form. So that we have to identify what is the right statement. If the relation should become 2NF, means what is the statement that we have to select. So coming to the first statement, all the values of non-key attributes are
dependent fully on the candidate key. Exactly. So within the second normal form, we have to follow this rule. All the non-key attributes are dependent fully on the candidate key. And coming to the next option, any non-key attributes that are dependent on only part of the candidate key should be moved to another relation where the partial key is the actual full key. Yes, it is also right option with respect to the 2NF second normal form. And coming to the last option, it must be already in the first NF. Yes, if you want to make one relation as which is in the format of second normal form, means it should be in the first normal form also. So now out of all the three options, all three are correct only. There is no doubt at all. And coming to the fourth option, all of the above are correct. So all the above we have to satisfy if you want to make any one of the relation which is in the second normal form. Here the right option is D. All of the above are the right statements with respect to the second normal form. Now coming to the next question, if one attribute is determinant of second, which in turn is the determinant of third, that means A is the determinant of B and B is the determinant of C, then automatically A is the determinant of C also. Then the relation cannot be, so here four relations are there, well structured, 1NF, 2NF and 3NF. As per the 3NF rule, so within the 3NF, if is there any relation, if you want to maintain 3NF, means the third normal form, means it has no transitive functional dependencies. But here A tends to B and B tends to C, in the sense A tends to C, it is a transitive dependency. We should not maintain it in the third normal form. Here the question is also, so then the relation cannot be, in the third normal form. If the transitive dependency is available, means that relation should not become the 3NF form. So now out of all the four options, the right option is D option. As per the rule given by the 3NF has no transitive functional dependencies. So that out of all the four options, D is the right option. The question here, we have one student table is there. Student table is available, and within the student table we have some attributes are there, like ID, which is of the type of integer, name, which is of the type of varchar2, and gender, which is of the type of character, and as well as date of birth, which is of the type of date. Now which of the following statement will execute successfully? Coming to the first statement, it is the question which is with respect to the insert query. Now the first query is insert into student values of S. The query syntax is correct. Insert into student is the table name, student values of, and coming to the first attribute, data type is integer, so that we can store integer 1 comma, and the name of the person, which is of the type of varchar2, we need to provide var character string. Especially within the Oracle database, if you want to provide the string, means we have to enclose it in the single quotes. So here we are providing the name of the person alias within the single quotes, there is no problem at all. But coming to the gender, here the gender we are providing it in the format of group of characters, but it is of the type of char. That means we have to provide only single character. Due to that reason, it is not at all correct option. Why? Because the gender is character type, that too we have to allow only single character, but we are providing multiple group of characters. Now come to the next option, insert into student values of 1 comma string. If you want to provide the string message, means definitely we need to enclose it in the single quotes with respect to the SQL Oracle database, but here we are using double quotes, so that it is not at all correct. Here we are facing the problem with the name of the employee, but what about the gender? There is no problem with the gender, we are providing only single character, that it is a char type. And next one is sysdate. Sysdate means you will get the current date and time with respect to the system, and which will, the data type of this sysdate is date type only, so there is no problem here. But the problem that we are facing is the name of the person we should not provide within the double quotes, we have to provide it in the single quotes. Within the Oracle database, the strings are acceptable in the format of single quotes, we have to enclose in the single quotes. Due to that reason, the second option is also wrong option. Coming to the next option, insert into student values of 1 integer type, no problem. Second, name of the person within the single quotes, no problem. And coming to the character, within the single quotes we are providing. But coming to the date, here the date we are providing in the format of, actually the data joining is in the format of date data type, but we are providing the joining date in the format of string, we are enclosing it in the single quotes. due to that reason here we are struggling, and this is not at all correct option. Come to the last option, insert into student values of one integer type, the name of the person within the single quotes we can provide it, and single character, the gender is single character, that's why we are providing single character. And coming to the date, within the date, so we can store null value also, there is no problem. Even though it is a date data type, the date of joining, we can store the null value, there is no problem. Now with respect to the D option, this is the right syntax, so that we can insert the data into the student table. Now out of all the four options, the right option is D option. Now coming to the next question, we have student table is there. Within that student table, four attributes are there. And first attribute is ID, which is of the type of integer, and there is no constraint upon the ID, so that we can store null value. Without providing the value also, we can there is no problem at all. We can insert the data into the table. So without using ID also, we can insert the data into the table. Why? Because there is no constraint upon the ID. As well as coming to the next attribute, name, which is of the type of string var char2. Here it is not null, we have the constraint upon the name. Definitely if you want to insert the data into the table, definitely within the name field you have to insert some name, otherwise it will not acceptable. And coming to the gender, this attribute, it is also, there is no constraint upon the gender, and the data type of the gender is character, that means you have to provide single character in the format of string. And here it is also optional, without providing the gender value as well as ID of the student, we can store the data into the database, there is no problem at all. But the mandatory fields, here name is the mandatory field, we have to insert some value into the name field, otherwise it is not at all acceptable. Why? Because upon the name we have the constraint not null. Coming to the date of joining, here the date of joining of the student is, which is of the type of date, and here the default constraint that is applying upon the date of joining is default system date. So now which of the following statements will execute successfully? Now coming to the first query, here it is a multiple choice question, we have to choose multiple options. Now insert into student, here we can insert the student data into in this format also. Here insert into student, here with respect to the student column names, ID, name, gender, date of joining, and the values are, one is the student ID, there is no problem, it is the integer type. Name is the student name, which is of the type of string, that we have to enclose it in the single quotes. And the gender in the sense we have to provide only single character, that we have to enclose it in the single quotes, so it is also correct. And date of joining, so the default constraint upon the date of joining is default sysdate, otherwise you can provide the null value also, there is no not null constraint upon the date, so that we can store the null value also, there is no problem, null will be storing into the date data type. So this is the right option, there is no doubt at all. And coming to the next option, insert into student of, we are providing the data for ID of the student and gender of the student. So ID and as well as the gender, for ID and gender we are providing, but we are missing one important attribute related information, that is name. Name is not null, the constraint that is applicable for the name is not null. Definitely you have to use it in order to insert the data into the table, but without using the name, we are simply inserting the data into the ID and gender, that means within the name the null value will be trying to storing into the name. Why? Because without using that name and as well as date of joining in this particular insert query, within that name and as well as date of joining, the null values will be storing. But unfortunately or fortunately, name is of the type of not null. Upon name we have constraints, so that it is not at all correct. You have to use the name and we have to provide the value with respect to the name, it is wrong option. Now coming to the C option, insert into student, here we are providing the ID of the student as well as name of the student, and that too name is of the type of var, that means it is of the type of string, we have to provide within the single quotes, yes. And that too it is a not null, due to that region definitely we have to provide the value, and we are providing the value. And here we are not providing the data for two important attributes, that the two important attributes are gender and date of joining, there is no problem. Without providing the values also, the default value that is available in the gender and date of joining is null, there is no doubt at all. And there is no constraint like not null upon the gender and date of joining, so that there is no problem. You can insert the data into the ID of the student and name of the student, and for the remaining two fields, gender and date of joining, you will get null values only. So it is also right syntax. Why? Because here we are mainly concentrating on the name, So we have to store the data with respect to the name of the student. Why? Because it is a not null. So it is the right syntax. Next, insert into student. The student attributes are id, name, gender and date of birth. With respect to the id, the value that we are inserting is 1, which is of the type of integer, no problem. And coming to the next one is name, but here in the name we are trying to store null. It is not at all acceptable. Why? Because upon the name we have the constraint not null. So with respect to it, it is also wrong option. Now out of all the 4 options, the right options are A and C only. So we can insert the data by using A and C options. We can insert successfully, we can execute successfully these 2 queries. Now coming to the next question, consider an empty student table provided below. An empty student table is there. Within that 4 attributes are there: id, name, age and date of birth. Id is of the type of integer, name is of the type of string varchar2, and age is of the type of integer, as well as date of birth is of the type of date. Following alter statements are successfully executed on this table sequentially, one by one. So altering in the sense we can modify the table schema. So now let me try to apply one by one. Alter table student, and that means we are trying to applying altering operation upon the student table, and here with the help of altering we are dropping 2 important attributes from the table. The 2 important attributes are date of birth as well as age of the student. That means after executing this alter command within the table we have only 2 attributes, that the 2 attributes are id and name only. Now coming to the next alter statement, alter table student, add one extra attribute. That extra attribute is gender, which is of the type of character. We have to provide only single character. Now we are adding one more extra attribute, that is nothing but gender, which is of the type of char, and only we have to provide single character. It is a gender. So gender. Now within this table, after completion of the second alter query, we have totally 3 attributes are there: id, name and gender. Id of the type of integer, name is of the type of varchar2, and gender is of the type of character. Now coming to the third alter statement, alter table student, modify name column we are trying to modify. We are modifying upon the name attribute, and that too the name data type is varchar2. We are modifying it into the number type. Number type in the sense it is of the type of integer. Now coming to the next alter command, alter table student, rename the column. What is the column that we are renaming? id. Initially the column name is id. We are renaming it to student id. Now it will become student id, std id. Let me try to write it in shortcut. Now this is the execution of the alter command. After executing all the 4 alter commands successfully, now the final schema of the table is, student table is, we have 3 attributes are there: student id, name, gender. Student id of the type of integer, name is of the type of number, it was modified, and coming to the gender of the student, which is of the type of character. Now what is the question? Which insert statement will execute successfully on this modified student table? Upon the modified student table, out of all the options, which is the right option to insert the data? Coming to the first one, insert into student values of, now id, which is of the type of integer, so that we can store 1. And coming to the name modified data type is number, but we are trying to store it in the format of string. We are enclosing it in the single quotes, so that it is not at all correct as per the updated table. Now come to the next insert command, insert into student values of, here 1, that means within the student id we can store the integer value, and 3 in the sense within the name of the student we can insert the number 3, we can insert, no problem. And coming to the next attribute, 30 in the sense the gender of the student, we have to provide it in the format of single character. We have to enclose it in the single quotes. Due to that reason, this second option is also wrong. Coming to the fourth option, insert into student values of, within the student id, which is of the type of integer, 1 we can store, no problem. And coming to the name of the student, here the name data type we are changing it, the updated data type is number, so that within the name we can store 3, there is no problem. And coming to the gender of the student, so single character we have to provide, and we are providing single character. So this is the right statement among all the remaining statements in order to execute successfully the command. Now coming to the last statement, insert into student Here it is not at all ID, it was updated student ID. Student ID, that is the thing that we have to do. Student ID comma name comma age comma date of birth. Here there is no age at all. We have already removed age attribute from the student with the help of alter command, so that it is also wrong statement. Now out of all the four statements, the right statement is C. With the help of C option, we can execute this particular query successfully with respect to the modified student table. Now coming to the next question, which of the following statements are true about distinct keyword? The first option is distinct keyword can be used in select and where class. No, within the where class it is not possible to use the distinct. We can use it in the select class. Here it is wrong option. Distinct remove duplicates based upon column immediately following by the distinct. No, distinct will be applicable for all the columns in the table, so that it is also wrong option. Coming to the C option, distinct remove duplicates based upon all the columns in the select class. Yes, it is correct. And coming to the last option, usage of distinct should be avoided as far as possible due to performance issues. Yes, we are going to get some performance issues, that's why we need to avoid it. In order to use it, it is not better to use it, you can avoid it, so that your query performance will be very better when compared to the uses of the distinct keyword. Now out of all the four options, the right options are C and D. Coming to the last question, consider a table employee within the two attributes are available, and the query is select name from the employee where salary between 1000 and 2000. Between, we are using between operator. So here between in the sense it will include the 1000 as well as 2000. The above query will display the names from the employee table whose salary. So here the first statement is the salary is greater than 1000. That means it is not including the 1000. And the salary is less than or equal to 2000. It is including the 2000. Less than or equal. That means 2000 also including in this particular statement. Here, but we are unable to include the 1000. More than the 1000 value only we are considering here. It is not correct with the help of between. Now come to the next statement, salary is greater than or equal to 1000. That means we are including the 1000 and above the 1000 value, and the salary is less than or equal to 2000. That means the less than 2000 value along with the 2000 also we are considering. It is the right option with the help of between. Now coming to the next option, salary is greater than or equal to 1000. That means we are including the 1000 and more than the 1000 values, but the salary is less than 2000. We are not including the 2000. It is not correct. Come to the last option, salary is greater than 1000. That means we are not including the 1000 value, and the salary is less than 2000. Here we are excluding 1000 and 2000. More than 1000 value we are considering, less than 2000 value we are considering the last option. It is also not correct. Here with the help of between, we need to consider, we need to include the both the lower bound value and upper bound value, and in between that values also you can get with the help of this query, so that the output is the employee salaries that we are going to get, the salaries who are having more than or equal to 1000 and less than or equal to 2000. So B is the right option among all the remaining options. Consider the table. We have two tables are there, one is store table and second one is sales table. So this is the store table and this is the sales table. Now which is the best primary key for the sales table from the following? Now from the following keys we need to identify which one is the best primary key for sales table. Now if you are going to observe within the sales table, if you are going to take store ID is as a primary key, is it possible to take it as a primary key? Try to identify it. So if you want to make any one of the column is a primary key in the sense within that column, so with respect to that column the data item should be unique, but here with respect to the store ID duplications are there, so we are unable to make this store ID as a primary key. It is not at all possible. So with the help of store ID we can't do anything. Now coming to the next one is product ID. Try to check within the product ID. If you are going to observe within the product ID column also we have some duplications are there. Product ID number 204 as well as that is repeating one more time, so that we are unable to make product IDs as a primary key in this sales table. Now coming to the description of the sales. Within the description of the sales, if you are going to observe here also we have some duplications are there, like biscuits are occurring 2 times. That means this description table we are unable to make it as a primary key. Actually the rule of the primary key is with the help of the primary key we can identify the row of the table uniquely. So primary key should be unique in the table. So with the help of primary key we can get the unique row data with respect to the given table. Now we are unable to make product ID as a primary key as well as store ID as a primary key and description as a primary key. That means with the available all the three columns we are unable to make primary key. But if you are going to combine two columns like product ID and as well as store ID, with the combination of the two columns we can have the flexibility to make primary key, and that too this combination of two columns we can call it as a composite key. With the help of composite key it is possible that the composite key is product ID comma store ID. Here with the help of product ID and store ID we can identify the unique rows. So here product ID with the combination of 204 we are getting 001, and with respect to the 204 we are getting some other store ID value that is nothing but 002. So like that here in this product ID there are two duplications, but for the two duplications there are two different IDs, so that with the help of product ID and as well as store ID we can have the flexibility to make the best primary key for the sales table. Now out of all the four options the right option is third option. The next question, here we have two tables are available, one is contractor and second one is construction. Now we have one query is there, it is a nested query, and here how many rows will be fetched when the above query get executed. Now if you are having nested query means first you have to perform inner query, after that we can perform the above query. Now within the inner query if you are going to observe, select contractor ID from contractor. Yes, we have contractor table is there. From the contractor table we have to identify the contractor ID where the number of constructions greater than or equal to 100. If you are going to observe within this contractor table, the contractor ID which is having the number of constructions greater than or equal to 100. So this first one which is having greater than or equal to 100, and second one as well as third one. But what about contractor ID 1004 and 1005? They are less than or equal to 100. Due to that reason we should not consider these two contractor IDs. Why? Because the number of constructions with respect to these two contract IDs are less than or equal to 100, less than 100, so that we should not consider them. Now coming to the this query output is, we will get three contract IDs. The three contract IDs are 1001, 1002, 1003. Now coming to the outer query, if you are going to observe outer query, select contractor ID from construction. From this table we have to identify the contractor ID. Yes, contractor ID column is available, and that too with respect to the construction table where the status of that contractor ID should be in progress. Now if you are going to observe within this table construction, so for the contractor IDs 1001 it is in progress, and for 1001 here it is in progress, and coming to the last contractor ID 1004 it is in the progress, and coming to the remaining two IDs for the remaining two contract IDs. So with the help of the outer query we will not get these two contractor IDs. Why? Because so that contractor ID related status is completed, but here in the question where the status is in progress, so that you will get these three contract IDs. One is 1001, 1001, 1004. Now here one more statement is available, and with the concatenation the contractor ID in this inner query. From the inner query the contractor IDs that we are getting are 1001, 1002, 1003. Now this particular contractor ID should be available in this particular contract IDs. Now here 1001 is available and 1001 is available one more time. That means we are getting two contract IDs. We will get these two tuples, and coming to 1004. 1004 is not at all available. Why? Because the contractor number of constructions is less than or equal to or less than 100, so that we should not consider it in the inner query. Now out of all the contractor IDs, here we need to consider only contractor ID 1001. It is in progress, as well as here one more tuple is there with respect to the contractor ID 1001. Here also it is in the process. Totally how many rows will be fetched when the above query gets executed? We are getting two rows. What are the two rows? First row is 1001, but here the bulling ID with respect to the contractor is different. if you are going to observe. So we will get 2 rows with respect to the nested query given below. Now out of all the 4 options, the right option is second option. Very simple. Now coming to the next question, consider the table sales information given below. Here we have one table is there, the table name itself is sales information. Within that 3 columns are there, region, salesman, sales. And here 2 members are there, Kade and Lisa have written queries to get the below desired output. So now coming to the first person query, here it is a simple query with respect to the first person, and the next query is belonging to Lisa, second person. Now the final question is, whose query will generate the desired output? So in order to get this output table, whose query is suitable, we need to check it. Now let me try to perform the first query with respect to Kati's information. Now with respect to the first person query, select star from sales information. That means we need to retrieve each and every record from the sales information, where the condition is we are taking one column, the column name is region. With respect to the region, whatever the words that are available, we need to convert them into lowercase, and here with the help of like operator we are using %t. That means each and every word should end with t. We have to identify, so in which word we are having the last letter is t. Now the first one, north, will come into the picture because the last letter is h, and west will coming into the picture. Why? Because the last letter will be t. So that here the option is west alone. You will get this first person details. Now coming to the next one, west. Here also within the last letter of west t only. Due to that reason we need to consider this particular person name West David. Next one is East John. Within the East John also, if you are going to observe within the region, the last letter is T, so that we need to consider it. The next one is East John. And coming to the next one, North Nolan. So within the North Nolan, if you are going to observe with respect to the region column, the last letter will be H, so that it is not at all matching with this condition. So we should not consider it. Coming to the South, within the South also the last letter is H, we should not consider it. Coming to the East, within the East the last letter is T, so that you can consider East no colors. Now with respect to this like operator, the output that we are getting with respect to the region column is West Ellen, West David, East John, and as well as East Nicholas. Now here along with this query we have AND operator is there, and we have some other statements are also available. Now we have to evaluate the remaining statement in the query. So within the remaining statement, with the help of logical OR combination, we need to take the salesman column, and that too within the salesman, how many number of words are there, we need to convert them into uppercase. And with the help of like operator, here we are performing %n. %n in the sense the last letter of the salesman should be capital N, or the first letter of the salesman should be capital N. So whenever we are going to convert this entire salesman related words into uppercase, all the letters will be available in the uppercase. Now each and every word, either last letter will be N or first letter will be N. So here Alan, we are going to get Alan. Why? Because within the Alan we are getting last letter as N. But if we are going to consider James, the first letter is J and last letter is S, we should not consider it. Here the first thing that we are getting here is Alan. With respect to the Alan, the region is West Alan. This is the first thing that we are getting. And coming to the David, it will not consider. Why? Because within the David, within the salesman column, D is the starting letter and D is the last letter. We should not consider it. Coming to the John, we can consider it. Why? Because the last letter of the John is N. We should consider it. So that with respect to the John, the region will be East and the salesman person name is John. Now come to the next one, Nolan. Within the Nolan, the first letter is N as well as last letter is also N. We can consider it. There is no problem. So here North Nolan also will be coming into the picture. Coming to the Nick. So within the Nick, the first letter is N, so that we can consider South Nick also coming into the picture. And coming to the last one, Nicholas. Within the Nicholas also the first letter itself is N. We need to consider it. East Nicholas. Now for this entire part we are going to get these many number of tuples, and coming to the first part, these are the tuples that we are getting. Here we are using AND operator, so that within the both the statements which are common we need to consider. So here in the both the statements in the query, West Alan is the common. West David is the common. No, West David is not at all available. We should not consider it. East John is common. Yes. Next, East Nicholas is common. What about next one? Here from these three outputs we are matching with the required elements, but here within this we are unable to match with North Nolan as well as South Nick. We are going to eliminate the two options. Now with respect to this entire query, the output that we are getting is West Ellen, East John as well as East Nicholas. So with respect to the first person query, we are getting this required output, so this is the right query. If you are going to take the second person query, try to check in the second person query what will happen. Select star from sales information, where a region we have to take with the help of like operator. So we need to consider the last two digits, the last two characters of the person should be end with th. If you are going to consider the condition, so within the north it will not consider. Yes, it will consider. Why? Because the end of the two characters are th. West is not considered. Here West is also not considered. East is also not countable. As well as within the north, the last two characters are ending with th. We can consider it, and south also we can consider it, but east we should not consider. Now with respect to this query, the tuples that we are getting are north, north, south, but within the output we are getting the regions west, east, east. So with that we can conclude that the second query is not at all getting this required output table. So with respect to the two persons, the first person query will be suitable in order to get this output table. So the right answer is first query. Coming to the next question, consider the table instruction given below. Here the table name is instructor. Now how many number of rows will be in the output after executing the below query? And coming to the query, it is the query which is having the clauses select from, where, group by, having. Now within that, select instructor id comma name from instructor. The table name is instructor, where the salary greater than 40,000. Now we have to identify what are the rows that are available with the salary greater than 40,000. So first row, the salary is greater than 40,000. Second row, third row, fourth row, but fifth row is, if you are going to consider, within that the salary is 40,000, but the condition here is greater than 40,000, so that we should not consider it. And last row, in the last row the salary is 50,000, which is greater than 40,000. That means we can simply eliminate the last before row. Now here group by, we need to perform group by operation upon instructor id and name. Now within the instructor id, if you are going to observe 1 to I201 as well as I201, we have to form one group with respect to the instructor id. With the help of same instructor id, we are going to form one group. And here instructor 201, it is only single id of the instructor that is available. We need to make it as a second group. Why? Because we are using group by class. And coming to the next instructor id, I203, it is available one more time, so that we can combine these two instructor IDs and we can make third group. So that here finally with the help of group by class, with respect to the instructor ID and name, we are forming three groups. In the first group, we are having the instructor ID I201 two times, and in the second group only one ID is available, that is instructor ID 202, and within the third group we have two instructor IDs, that too the ID is instructor 203. These two are belonging to third group. Now after group bying that instructor ID and name, here performing the having class. Having, we have to identify the count. Within the count, distinct university greater than 1. So now let us consider the first group. With respect to the first group, two IDs are available, instructor ID 201 as well as instructor ID 201. We have to identify what are the universities with respect to the two instructor IDs? Here we are getting Harvard and Harvard. Harvard and Harvard in the sense, so these are all belonging to single university only. There is no distinct universities. Here only the distinct university is Harvard University, and which is not at all greater than 1, so that we should not consider the first group as a output. Why? Because within the first group we are having only one distinct university which is not at all greater than 1. We should not consider the first group now. Now coming to the second group, within the second group we have only one instructor ID 202, and that too within this instructor ID we are having only one university which is not at all greater than 1, so that we should not consider the second group also. Now coming to the third group, within the third group we have two instructor IDs are there. Instructor ID 203, it is repeating one more time, and with respect to the two instructor IDs we have two different universities are there. Distinct universities count here is greater than 1. Due to that reason we are going to get the output as a single row with respect to the third group. With respect to the third group, the instructor ID will be I203 and the instructor name will be Mitchell. So this is the output that we are getting as a single row. The third group we are getting in the format of single row output. So here, as per the question, how many number of rows will be as the output for the below inquiry? Here we are going to get only one row as a output, and that too, that is the third group. And here, consider the following record of the customer table. So here within the customer table we have one column is there. The column name itself is last name. Within that column we have one item is available. The last name of the person is D'Souza. Now what will be the output of the following query? Select the length of, and within the length function we are passing substring function. Within the substring we are passing the main string last name. That means you will get the complete last name D'Souza here, and here the length of the last name is 1 2 3 4 5 6 7. 7 characters are there in the last name. Now from this last name we need to identify the substring, and that too from the character 3 to up to 7. Character 3 to 7 in the sense 1 2 3. Here from the character 3 to 7th character 3 4 5 6 7 up to here. If you are going to consider it as a substring, so with the help of this substring function we are going to get this substring, and the length of this substring is 1 2 3 4 5. Totally 5 characters are there in the substring. So out of this entire query the output that we are getting is 5. Now within the 4 options the 5 is available in the second option. It is the right option. Coming to the next question, consider the following record of the customer table. Here in the customer table one column is there. The column name is ACCDT, and within this column we have the date is available 8 Jan 30, and which of the following query displays the data in the following format. Here we have to print the data in the above table in this required format. Within this format if you are going to observe we are getting two columns. That the two columns are, one is day and second one is month, and here we are printing the day value as well as here within the second column with respect to the second column we are printing the month value. In the date format in the Oracle it is always in the format of DD, MM and YYYY. DD in the sense date format, here date we need to represent, and here MM in the sense we have to provide the month number, and YYYY in the sense we have to provide the year. Now out of all the 4 options we have to choose the right option in order to get this required output. Now if we are going to consider the first output, select to_char. Here we are passing dy and mon. So the date format should be available in the format of dd and mm. So we should not use dy or mm, so that month, so that it is the wrong option. And coming to the second option also, within the second option also dy and mon we are using in order to represent the date and as well as the month of the given date, so that it is also not at all correct option. And coming to the third and fourth option, in the both third and fourth option we are using dd format and mm format. That means these are the two predicted outputs for the given output table. Now out of these two options we have to choose the right option. In order to choose the right option you have to know what is the functionality of to_char. So in the Oracle the to_char function converts a date or interval value to a string in a specified date format. So with the help of to_char we can convert the date or interval value to a string in a specified date format, or the Oracle to underscore char function is very useful for formatting the internal data returned by a query in a specific date format. So here, with the help of toChar only, with the help of this function only, we are going to print the date into the required string format, so that out of all the four options, this is the right option. We should not consider the fourth option. Why? Because here the function that we are using is to underscore date. The to underscore date, we need to use it when if you want to convert the character or varchar type, if you want to convert it into the date type, at the time you have to use it. But already the date is available, we need to convert into the required string format. That's why we are using to underscore char. Now select to underscore char of from the account dt, comma, we need to print the date in the format of dd, and with respect to the date, we are taking the column name day, comma, to underscore char of from the account dt that means it is in the format of month, and the month name itself is mon from the customer. So this is the right query in order to print the output in this format. Fourth option is also wrong option. Out of all the four options, the right option is C option. Now coming to the next question, which of the following aggregate functions can be applied on both number and character types columns? Now one thing you have to remember, both the sum and average, we can apply them upon the numeric fields only. We should not apply them upon the character type columns. So as per this explanation, if you are going to identify within these all options, we have sum is available as well as average is available. The sum and average, we can apply them upon the numeric data types only. We should not apply them upon the combination of numeric data type as well as character type columns, so that we can eliminate them. Apart from these two options, remaining all options, min, max and as well as count, we can apply them upon both number and character type columns. There is no problem at all. So that the right options are A, B as well as D. Here the right options are min, max and count. Coming to the next question, table T exists with a single column A having 4 rows with the values 100, 200, null and 300. What is the output of the following query? Here table T, the table name is T, which is having single column. Within that single column, the column name is A. With respect to the single column, we have 4 rows are available. Within the 4 rows, the values that are, the first value is 100 within the first row, the second value is 200 in the second row, and the third value is null. That means nothing is available in this third row, as well as 300 is the value that is available in the fourth row. Now what is the output of the following query? The query is select max. We are using aggregate function, max of A. That means with respect to the column A, we have to identify the maximum element from the T in the sense from the given table, where that A greater than 1000. That means we are using relationship operator within each and every row, whatever the value that is available. If it is greater than 1000 means, then only we need to consider it and we need to find out the maximum element. But unfortunately, as per the air condition, it does not satisfy the given elements in the column A. It does not satisfy. Why? Because here within the air condition, we are always checking each and every value that should be greater than 1000, but none of the values are greater than 1000, so that from this entire query nothing will be printed, nothing will be returning. Okay. However, the maximum value of nothing is null in the Oracle database. In SQL, null is the absence of the information. If nothing is returning from the query means the output we have to represent in the format of null. It's the natural choice when the database cannot find the data. If that means if the query, as per the given query, if the data is not fetching from the given table means, we can have the flexibility to print null value in the absence of information, so that for this query we are not at all getting anything, and that too for that anything we are representing it in the format of null. So out of all the 4 options, the right option is B option. Now coming to the next question, between operator can be replaced by dash as well as in operator can be replaced by dash. We have some options are available. We need to choose the right option, so that within that option, whatever the operators that are available, we need to replace them with respect to the between and in operators. Now coming to the functionality of between and in. So before going to enter into the functionality of each and every one, First you have to know both the between and in operators will return boolean value only. Boolean value means either true or false. Now coming to the functionality of the between operator. So between and 200 means we have to consider the values within the range. We need to include 100 as well as 200 also. So both are inclusive with respect to the between. Now let me try to provide some value here. 100 in the sense, yes, as per this condition between 100 and 200, 100 is greater than or equal to 100 and 100 is less than or equal to 200. So the between operator will return true with respect to the 100 value. If I am going to pass 110 with respect to the 110 also, 110 is greater than or equal to 100 and 110 is less than or equal to 200. So that for this 110 also between operator will return true only. If I am going to pass 200 with respect to the 200, 200 is greater than or equal to 100 and 200 is less than or equal to 200. So that between operator will return true only. If I am going to pass 201, what will happen? Try to check it. Be careful here. So 201 greater than or equal to 100. Here we will get true, and 201 less than or equal to 200. Here the condition fail. Condition fail in the sense you will get false. True and false means finally the between operator will return true, and false means you will get false only. That means the between operator will return false. So as per this explanation, the between operator can be always replaced by AND operator. If you are going to check the AND operator, we are having that option in both B and as well as D. These two are the expected output answers. Now coming to the next line, in operator can be replaced by dash. So in operator functionality that you have to know now. In operator in the sense whatever the values that I am providing, as per that values, for example, I am going to provide 100. 100 is available out of all the values that I am providing in the in operator. So 100 is available out of all the values. Here two values are there, 100 and 200. At least any one of the values should be 100, so that in operator will return true. If I am going to pass 200, out of the two values, any one of the values should be 200. Yes, 200 is available here, so that in operator will be returning true here. If I am going to pass 105, none of the value in the in operator is 105, so that it will return false. That means at least any one of the values should be matching with the required input. So in operator we can replace it with the help of OR operator. We need to check in which option we have OR operator instead of in operator. Within the D option we have OR operator. So out of these two options, the right option is D option. B also wrong. First option is wrong, second option is wrong, third option is wrong, and finally D is the right option. We can replace between operator can be replaced by AND, in operator can be replaced by OR. Coming to the next question, which of the following statements will execute successfully? Here four statements are there. It is a multiple choice question. We can choose multiple answers. And coming to the first option, insert into student. Student is the table. Insert into student. It has four attributes: ID, name, gender, and date of join. Insert into student of, for these four attributes we can insert the values, and at the time of inserting the values you have to be careful. Why? Because with respect to the given data types we have to insert the values. Now with respect to the ID, the value that is assigning is 1. With respect to the name is of the type of string, that's why we are providing the name in the single quotes. And as well as the gender in the sense we can consider it as a char, we have to provide only single character, as well as the date of joining, which is of the type of string. So here the date is available in the format of string. As for the four attributes, we are providing the four values. There is no doubt at all. So that's why this first option is the right option. Coming to the second option, insert into student. Here also student table. Within the student table, four attributes are there: ID, date of joining, name, and gender. Now as per the ID, the values that we are inserting here is, as per the ID, one is inserting date of joining. We can provide the current system date. There is no problem at all. We can call the sys date, so that the current date and as well as the time we are going to get with respect to the date of joining. And the name of the person Alice, and as well as the gender of the person is female. There is no problem at all. So this second option is also right option. With respect to the number of attributes, the number of values are available and the data types are also matching. Coming to the third option, insert into the student. Within the student, four attributes: ID, name, and gender, as well as date of joining. and the values that respective to that all the 4 attributes are, if you are going to count the number of values, 1, 2, 3 only. 3 values we are providing, but the attributes that we are providing here are 4. That means for the 4 attributes, actually we have to provide 4 values, but we are providing 3 values. It is a syntax error. It is not at all correct option in order to insert the student data. Come to the last option, insert into student of. Here also 4 attributes are there: id, name, gender and date of joining, and the values 1, 2, 3, 4. 4 values we are providing, but we need to check the data types also. With respect to the id, the value that we are inserting is 1. There is no problem, which is of the type of integer. Coming to the name, name which is of the type of varchar2, there is no problem. Coming to the gender, here the gender, instead of gender we are inserting the date. So within the gender we should not insert the date, we have to provide the single character, either male or female. And as well as within the date of joining, we have to provide the date, current system date, or we need to provide the date in the format of day, month as well as year. But instead of providing date of joining, we are providing the gender here. That means data types are mismatching here. Even though we are providing 4 values out of 4 attributes, here the data types are mismatching, so that this data will be not at all inserting into the database. Now out of all the 4 options, the right options are first and second options. Very simple. Coming to the last question, one insert statement can be used to insert how many number of rows? Only one row, a maximum of 100 rows, a maximum of 1000 rows, any number of rows. Here insert query has two syntaxes. The first syntax is insert into student. If you are having student table, student values of, directly we can insert the values with respect to the number of attributes which are available in the student table. With respect to this insert query, at a time we can insert only one row. But we are going to take another syntax, insert into student within the student table as per the number of attributes, attribute 1, attribute 2, attribute 3. Like that 3 attributes are available in the student table means we can insert the values of the student table with respect to the address location of the each and every attribute, with respect to the ampersand att1, ampersand att2, as well as ampersand, here I forgot to mention ampersand, so ampersand attribute 3. So that if you are going to use this syntax, with the help of this syntax you can insert as many number of rows as possible. So we can enter the first attribute name, second attribute name, third attribute name. After that we need to enter the forward slash, then you can insert another row data. Like that we can insert as many number of rows as possible with the help of the second alternative in the insert statement. Now with the help of first alternative we can insert only one row at a time. With the help of second insert statement we can insert as many number of rows as possible. Here there is no information about what is the syntax that we have to use for the insert query, so that out of all the 4 options we have the flexibility to use any one of the syntax with respect to the insert statement. So as for the insert statement, you can insert as many number of rows as possible. Any number of rows we can insert. Out of all the 4 options, the right option is D option.
Joins concept in the SQL. So generally what do you mean by the join? A join clause is used to combine rows from 2 or more tables. That means we can apply this join clause upon the 2 or more tables, and we can combine the 2 or more tables data at a time based upon the related column between the 2 tables. Now there are 4 types of joins are there in the SQL. That the 4 types are inner joins, left outer join, right outer join, as well as full outer join. Now let me try to concentrate on the inner join. What do you mean by inner join? Inner join in the sense it will return the records that have matching values in the both the tables based upon the related column. Now if you are going to consider this example, here employee table is there. Within that employee table we have 5 fields are there: employee ID, employee name, city, as well as salary and age. And we have one more table is there, project table. Within that project number, employee ID and department. Here if you are going to observe, within these 2 tables employee ID is common. Now with the help of inner join, if you are going to apply the inner join upon these 2 tables, it will return the records that are matching the values in the both the tables based upon the employee ID. Now here inner join in the sense you will get the intersection among the 2 tables. That means the common data that is available in the 2 tables. Now let me take one example query. Here the query is select employee.employee name. From the employee table we need to get the employee name, as well as from the project we need to get the department. From the employee, where it is going to join with the help of inner join in the project table, And here the condition is, with the help of on keyword we are applying the condition. The condition is based upon the employee ID in the project. Here in the project table we have employee ID is there, which is equivalent to the employee ID in the employee table. So the ID which is matching in the project table is with respect to the employee table. Based upon that ID we are going to get the records with the help of this inner join. Now if you are going to observe from the project table 1, 2, 3, 4, these 4 IDs are available in the employee table also. So that with the help of inner join, so as per the definition of the inner join, we can return the records that are having matching values in the both the tables based upon the related column. Here the related column is employee ID, so that within the both the tables the common employee IDs are 1, 2, 3, 4. But unfortunately 5 and 6 are not available in the project table, as well as the employee ID 7 and 8 are not available in the employee table, so that we can omit that, we should not consider them. Apart from that remaining rows, here the common rows with respect to the employee IDs which are same in the both the tables are 1, 2, 3, 4. As per that 1, 2, 3, 4 employee IDs, we need to get employee name in the employee table as well as the department from the project table. Here the employee name in the employee table is Ramu, Rahul, Suresh, Ramesh, who are having the employee IDs 1, 2, 3, 4, as well as from the departments, as per the employee ID 1, 2, 3, 4, the department category here is testing, development, designing, and as well as development. Now if you are going to observe the output with respect to this inner join query, here from this entire two tables we are getting common rows with respect to the employee name and department. That the common rows are Ramu, Rahul, Suresh, Ramesh, which are who are having the same employee IDs with respect to the project table. Here 1, 2, 3, 4, 1, 2, 3, 4. So that with respect to the 1, 2, 3, 4, the employee names are Ramu, Rahul, Suresh, and Ramesh, as well as the departments are testing, development, designing, as well as development. Here the final output is, with the help of this inner join we are getting the common data from these two tables based upon the employee. That's all. It is very simple. Now coming to the next join operation, left outer join. Now what do you mean by the left outer join? All of you please observe here. It will return all the records from the left table and the matched records from the right table based upon the related column. Now the related column that we are taking here is employee ID with respect to the two tables. Now let me try to explain the query here. Select employee dot employee underscore name. From the employee table we need to get the employee name, comma, from the project table we need to get the department of the employee. From the employee table, as well as employee table is involving in the left join with project table, and here the condition is, with the help of on keyword, here we are the condition that we are applying is, from the project table if the employee ID is matching with the employee ID in the employee table. Here the matching IDs from the project table are 1, 2, 3, 4, which are available in the employee table also. Here 1, 2, 3, 4 are available in the employee table also. Now with the help of left outer join, if you are going to observe the definition, it will return all the records from the left table. You will get all the employee names from the left table, and only we are going to get matched records from the right table. Matched records in the sense, so within this only 1, 2, 3, 4, only 4 IDs are matching with the employee table. So that if you are going to observe this Venn diagram, here table 1 is there, table 2 is there. You will get all the records from the table 1, that is nothing but left table, but only matched content in the table 2. So here with respect to the employee ID, so here you will get the all the rows, all the employee names from the left table, Ramu, Rahul, Suresh, Ramesh, Mahesh, Sita. But unfortunately Mahesh and Sita, if you are going to observe these two persons, the persons employee IDs are 5 and 6, which are not at all available in the project table. So that for these two persons we are unable to identify the departments names in the project table. So whatever the IDs that are matching with the employee table, with respect to that IDs 1, 2, 3, 4, we are getting the department names for the employee names. For Ramu, the department that we are getting here is testing. For Rahul, we are getting development, as well as for Suresh, we are getting designing, and for next person Ramesh, we are getting development. But for Mahesh and Sita, we are getting left table complete rows. With respect to the Mahesh and Sita, that matching data and matching IDs are not available. The IDs with respect to the Mahesh and Sita are 5 and 6 which are not at all available in the project table. Due to that reason, for Mahesh and Sita, we are unable to identify the department name, and due to that reason, you will get the department names are null here. So if you are going to observe this output table, from the left table we are getting all the rows, and that too within the right table. From the right table we are getting only matched IDs, employee IDs related departments, that are testing, development, designing and development with respect to 1, 2, 3, 4. But we are not getting Mahesh and Sita related department names. Why? Because those IDs are different when compared to the project table. That's all. It is very simple. Now coming to the next join operation, right outer join. Now what do you mean by right outer join? Right outer join in the sense it will return all the records from the right table and the matched records from the left table. Here employee table is the left table and project table is the right table. If you are going to observe the Venn diagram, you will get all the records from the right table. Why? Because we are applying right join operation, and as well as only the matched content with respect to the column in the right table. From the left table we are going to get the matched content only. Now let me try to explain the query here. So select employee name from the employee table as well as department from the project table from employee, which is applying upon the right join operation upon the project table. That means these two tables are in the process of application of right join operation, and here the condition that we are using is based upon the column ID employee. If the employee ID in the project which is matching with the employee ID in the employee, so that related matching related employee names only we need to get from the left table. Why? Because from the left table with the help of right outer join you will get the matched content. From the right table you will get the complete rows. So here in this both the tables only employee 1, employee 2, employee 3, employee 4. This 1, 2, 3, 4 IDs are matching with the employee table in the employee table. These are the IDs which are matching with the project table. So from the right join operation from the project table, it is the right table, you will get all the rows. That the rows are nothing but from the project table we are getting the department data, testing, development, designing, development, deployment as well as designing. All these rows we are going to get into the output. If you are going to observe the output table, we are getting testing, development, designing, development, deployment and designing. But the IDs which are matching in the employee table with respect to the project table, that matched content from the right table we are getting. That matched content in the sense from the employee table we need to print the employee names. So the IDs which are matching with the employee table in the project table, that IDs related employee names only we are getting in this particular example program. Now here we are getting Ramu, Rahul, Suresh and Ramesh. Why? Because for these employees the employee IDs are 1, 2, 3, 4 which are matching in the project table. Due to that reason from the left table only the matched content. From the left table we are getting matched record from the left table. So here the matched records are Ramu, Rahul, Suresh and Ramesh. You will get them in this particular output table. But unfortunately for the last two records in the right table, for the deployment the employee ID is 7 which is not at all available in the employee table. Due to that reason from the employee table there is no name which is with respect to the employee ID 7. Due to that reason we are getting here null. As well as for designing which is having the employee ID 8, for the designing phase that employee ID is not at all available in the left table. Due to that reason for the designing department also the employee name that we are getting here is null only. It is very simple. Now coming to the last join operation, it is a full outer join or full join. Now as per the definition of the full join or full outer join is, it will return all the records whether there is a match in either left or right table. So irrespective of the matching, you will get the two table data completely. Here if you are going to observe the Venn diagram, full outer join means you will get two table data completely. Now I am providing here one important note, all of you please read it. The full outer join keyword return all matching records from both tables whether the other table matches or not. So if there are rows in the employee table that do not have matches in the project, or if there are rows in the project that do not have matches in the employee, those all the rows will be listed as well. Now as per the full outer join, if you are going to observe,
from the both the tables. Here the query is select employee name from employee, comma, department from the project from employee table, which is full join with the project table, and here the condition is within the two table with respect to the employee ID. Here the employee IDs are matching with the project employee ID 1, 2, 3, 4, which are matching with the employee ID 1, 2, 3, 4. You will get these records related data, that means employee names as well as department names you will get, along with them remaining data also. The employee IDs which are not matching with the project table as well as the project employee IDs which are not matching with the employee table, you will get those records also. But the problem here is, if you are going to observe, with the help of full join, you will get the matched content completely. The employee name with respect to the department, with respect to the first employee ID, the name is Ramu and the department of the employee is testing, and the second employee ID which is matching with the employee table, so that Rahul and the department of the Rahul is development, as well as with respect to the third employee ID which is matching in the employee table, Suresh, the employee name is Suresh, and as well as the department of the employee is designing. And coming to the fourth ID which is matching in the employee table, the employee name is Ramesh, and as well as the department of the Ramesh is development. You will get the full data with the matching records. But if you are going to observe from the employee table, 5 and 6 employees, we are having employee names, but unfortunately these IDs are not at all available in the project table. Due to that reason, for these two employees with employee IDs 5 and 6, the department values that we are going to get here is null. As well as for the employees who are having the employee ID 7 and 8, for them the IDs are available in the project table, but that IDs are not at all available in the employee table. Due to that reason, for this employee ID 7 and 8, we have the departments, but we does not have the name of the employee. Due to that reason, from the two table, if you are going to observe, for the matching IDs 1, 2, 3, 4, we are getting employee name as well as employee IDs, employee departments. But for the not matched content, for fifth and sixth rows, for fifth and sixth employee IDs, we are getting only employee names, but the departments are null. Why? Because those IDs are not at all available in the project table, and that respective department names are also not available. As well as for the employee ID 7 and 8, the department names are available, but the employee names are not at all available. Why? Because 7 and 8 employee IDs are not at all available in the employee table. Due to that reason, we are getting deployment as well as designing for the employee ID 7 and 8 in the project table, but we are unable to get the employee names. Here we are getting the complete records from the two tables. So that the records are Ramu, Rahul, Suresh, Ramesh, Mahesh, Sita, as well as all the departments like testing, development, designing, development, deployment, as well as designing. For the matched content only, we are getting employee name and non-department. That's all. I think with this, you got the complete idea related to all the four join operations.
Here in this question, given the employee and computer tables as input, here two tables are there, employee table and as well as computer table. Choose the query which produces the result table as shown below. It is the result table. In order to produce this result table, what is the query that you have to choose? If you are going to observe, it is a multiple choice questions. You can choose multiple options. Now, employee table is the left table and computer table is the right table. Let me try to apply the first query. What will happen? So here from the employee we are selecting ename, EID, ename, as well as from the computer table we are selecting computer ID and computer model. So in the output table also we are getting EID, ename, computer ID and computer model. And from employee E, which is joining, here we are using join operation, that the join operation is left outer join with the computer table C. On the condition, here the condition is E dot computer ID is equal to C dot computer ID. So here in the both the tables, the column computer ID is common. Now if you are going to observe, whenever we are going to apply left outer join, you will get the complete row information from the left table and as well as matched content from the right table. Here as per the computer ID,
the matched content in the both the tables are 1001 ID. So that means from the left table you will get the complete information, all the rows in the sense with respect to employee ID, employee name, as well as computer ID and computer model from both the tables. So in the left table you will get all the employee IDs like 1, 2, 3, as well as employee names James Potter, Ethan McCarthy, and as well as Emily Rainer. You will get all the employee names as well as employee IDs, but in the right side table, as per the left outer join, only the matched content will be getting. Matched content in the sense for the employee ID 1 as well as the computer ID 1001, for that particular employee only you will get the model. So the model itself here is Vastro. We will get the Vastro computer model. But for remaining all the employees, we are unable to get the model, and here you will get the null value. But within the table, if you are going to observe, only one row is there, and that too the row is with respect to the employee ID 1 and as well as the computer ID 1001. Now, as per this left outer join, we need to get all the rows in the left table, but unfortunately we are getting only one row in the table, and that too that row is matching content in between the two tables. That means it is a inner join operation, it is not at all left outer join operation. This result is completely related to the inner join operation. Inner join operation means only the matched content in the both the tables with respect to the computer ID you can get it. Due to that reason, the first option is wrong. If you are going to observe the second option, from the query, select e dot id, e dot name. From the employee table, we are getting id and as well as name. And c dot computer id, that means from the computer table we are getting computer id. C dot model, in the sense from the computer table we are getting model. Totally 4 rows we are retrieving. 4 columns we are retrieving. Sorry, we are retrieving 4 columns. That the 4 columns are eid, ename, computer id, model. And here from the employee, here we are applying left outer join with the computer table, and that too based upon the condition. Here the condition is e dot computer id. From the employee table, the computer id which is equivalent, which is matching with the c dot computer id. C dot computer id, in the sense from the computer table the matching computer id. Here in the both the tables the matching computer id is 1001, but unfortunately the join operation that we are applying here is left outer join. That means you will get the complete row information from the left table and only the matched content from the right table. As per the previous option, you will get the same output up to here, but here in this option we are including one more line, that one more sentence. That sentence is we are applying where class. What is that where class? Where c dot computer id is not null. So that means the computer id which is not null, that information only we need to produce. So with the left outer join you will get all the employee details. For that all the employee details, if you are going to consider second employee and third employee, the computer id is null. But in this question we are including one where class. Within that where class we should not get the rows which are having the computer id is null. Where c dot computer id is not null means we should not retrieve null related computer id rows. Due to that reason only, even though we are applying left outer join operation here, only as per the computer id in the both the tables you will get only one row. That row is 1001 related computer id. So with respect to that computer id of the employee is 1, employee name is James Potter, as well as computer id is 1001 and the model is Ostro. Due to that reason, this second option is right option. Even though we are applying left outer join operation based upon the where class, we are eliminating the computer id values which are having null. Now let me try to apply the C option. Within the C option, if you are going to observe, from the C option also we are selecting employee id, employee name, as well as computer id and computer model from employee table, which is joining with the computer table with the help of right outer join. And here right outer join means you will get the complete data from the right table and only the matched content from the left table. So the matched content from the left table means you will get only James Potter 10001 related row. You will not get the remaining all the rows. But from the computer table you will get the 2 rows. But in the output we are getting only 1 row. Due to that reason you can eliminate this option. Right outer join in the sense you will get the complete information from the right table, all the rows from the right table and only the matched content from the left table. That means here totally you will get 2 rows, but unfortunately within the table, within the resultant table only 1 row is there based upon the condition computer ID. From the employee, the computer ID which is equivalent to the computer ID in the computer table. So here it is wrong option. Now let me try to apply the fourth option. Select EID ename from the employee table, C.computer ID C.model from computer table, where the employee ID is joining with the computer employee table is joining with the computer table. Here the join operation that we are applying is inner join. Inner join in the sense only the matched content based upon the condition. On the condition is where E dot computer ID is equivalent to the C dot computer ID. From the employee table, the computer ID is 1001, which is equivalent to the computer ID in the computer table 1001. That means you will get this matched content only. The matched content in the sense only this row from the employee table as well as the first row in the computer table. From this particular first row in the both the tables, the required content that we have to print here is select ID name from the employee table, computer ID and computer model from the computer table. So we are getting one James Potter from the employee table as well as 1001 first row is from the computer table. Only matched content from the both the tables we are printing with the help of inner join operation, so that it is also right option. Now out of all the 4 options, the right options are second and fourth. That's all. It is very simple. Now coming to the next question, we have two tables are there, employees table and departments table. Within the employees table, 3 columns are there, last name of the employee, department ID of the employee, salary of the employee, as well as within the departments table, department ID is available, department name is available. In the both the tables, if you are going to observe, department ID is common. So in the first table, the second column is department ID. Within the departments table, the first column is department ID. Now here the question is, you want to retrieve all employees. That means here the employees table is the left table and departments is the right table. We want to retrieve all the employees whether or not they have matching departments in the department table. That means irrespective of the matching condition, the departments are matching from the employees to the departments, we need not to bother about it. So whether or not they are matching with the departments in the department table, we need to get all the employee related information. That means all the rows from the employee table. So which query would be suitable here? Very simple. Irrespective of the matching condition, we need to get all the records from the employee table. Means employee table is a left table. Here we need to apply left outer join or left join concept. Now let me try to check. So within the first query, if you are going to observe, select last name from the employee table, department from the department table, from employee E, which is left outer join with the department D on the condition employee dot department ID is equivalent to department dot department ID. Now here we are applying left outer join. Left outer join means you will get the complete all the rows data from the left table, that is nothing but employee table, and only the matched content from the right table, that is nothing but as per the given condition. Here department ID we need to check. So within the both the tables, department ID 10 is matching, department ID 20 is matching, department ID 30 is matching. So now as per this, in the right table you will get only 10, 20, 30 department names. ME sales marketing, only sales marketing accounts only we are getting from the department table. But employee table, even though the record here, the last record with a salary 5,000 which is not at all available. The department ID is not at all available for the last name Kochar here. So even though the condition is not matching, with the help of let out join, you will get all the employee last names. Here the department ID that we are going to get in the output table is null. Why? Because the department ID is not at all available in the departments table. So you will get all the records irrespective of the matching condition. So that out of the three options, A is the right option. Let me try to explain the remaining options also so that it will be very easy for you. Select last name comma department name from the employees. Here we are applying a right outer join. Employee table is right outer join with the departments table on the condition department ID matching. Now right outer join in the sense here you will get the complete rows from the right table but only the matched content from the left table. Complete rows means you will get all the department names, sales, marketing, accounts and administration, but from the left table you will get only the content with respect to the matching IDs 10, 20 as well as 30. So 10, 20, 30 in the sense you will get only 4 records, you will not get the last record. So why? Because it is a right outer join. In the right table you will get all the department names, but the department name administration, that related department ID is not at all available in the employee table. So that as per the department name administration, so the last name you will get null. Why? Because as per the 40 administration department ID, the name is not at all available, last name is not at all available in the employee table. Due to that reason, for that department name you will get last name is null. But here in the query we need to get all the records from the employee table. Due to that reason we have chosen first option. So this is wrong option. Let me try to go to the last option. Select last name comma department name from employee. Here we are applying full outer join. Full outer join in the sense you will get both the table content completely, all the rows from the both the tables along with matched content and not matched content. As per the explanation given by me in the previous video, full outer join in the sense you will get both the table data. So either of the table data is matching, that is more than enough. So you will get the full table data. From the first employee you will get all the records, as well as from the departments table you will get all the department names. So but here we need to get only in the question, we need to get all the employees related records. We don't bother about departments related records. Due to that reason, only A is the right option and C is also wrong option. It is a very simple question.
Here in this question, we have one table is available. The table name is person. And this is the table structure. Within this table, totally 3 attributes are there: ID of the person, name of the person, and as well as date of birth of the person. So here this is the data about the table. Within the person table, totally 4 persons details are available. So we have 3 queries are available. So at the end of this execution of all the 3 queries, what is the outcome of the queries given above? Now the first query is, can you please concentrate? Select count star from person where the date of birth like 01 percentage. So the date of birth like 01 percentage in the sense, so the given pattern, within the given pattern date of birth, if the starting 2 characters are, the start of the pattern is starting with 0 and 1, we need to consider them. So here in the date of birth, if you are going to consider, so in the first date of birth we are starting this entire date of birth with the 01, so that we need to consider it. So this is the output. And as well as in the same date of birth we have one more date of birth is available, and here also the starting 2 characters are 0 and 1, so that it is also considerable. So at the end of this query execution, you will get these 2 rows as a output. So that here the count star from the person where the date of birth like 01 percentage, in the sense the starting of the pattern should start with 01 followed by the percentage, in the sense 0 or 1 or many number of characters. So 01 followed by many number of characters, or 0 characters, or 1 character. So 01 is the starting character, so that we can consider it. So for this query the output is, you will get 2 rows. Now here in the all the 3 options, if you are going to observe, first option is eliminated. Why? Because for the first query in the first option we are getting 0 rows, it is not at all correct option. So consider the second option. Here in the second option we are getting two rows, so it is the expected right answer, and as well as, so in the third option also again we are getting two rows, it is also expected right answer. Now let me try to execute the second query. The second query is select count star from person where date of birth like percentage 14. Percentage 14 in the sense, so 14 is the end of the pattern, so we need to consider 14 is the end of the given date of birth column. So the date of birth which is having 14 is the end of the given string. We need to consider it as a expected outcome from this query. So now here, out of all the data births, two data births are having same answer. The same answer is at the end of the date of birth we are getting the last two characters are 1 and 14. So it is also considered, first option is considerable, and as well as third option is also considerable. Why? Because in the third option also we are having 1 4 is the end of the string. So we are going to consider this 1 4 is a output. For this query we are getting two outputs. The two outputs are first row and as well as third row. From this query you will get two rows as output. So in the second and as well as the third option we are getting two rows for the second query also. Let me try to execute the third query. What is the third query? Please all of you observe. Select count star from person where date of birth like percentage John percentage. Percentage in the sense 0 or 1 or many number of characters followed by the John followed by 0 or 1 or many number of characters. That means in the middle of the pattern we should identify the John substring. So now, so we need to check it in the date of birth column. So in the date of birth we are having John in the uppercase, but here the pattern that is available in the format of J capital A N small. So it is not at all considerable. First row is not at all considerable. John is available, but the thing is here the substring is in the uppercase letters. We should not consider it. And March is not at all. MAR is not at all matching with the John. We should not consider it. And as well as here one more row is there within the date of birth. Within the date of birth we are getting Jan as a substring, but unfortunately all the letters in the Jan are uppercase, so that we should not consider it. Why? Because here we are providing J capital A N small, but the available subpattern is having all letters in the uppercase. We should not consider this row also. And as well as this John is not at all matching with the June also, so that we should not consider this row also. So for this query, for the third query, the expected output is we are going to get 0 rows from the available table. So out of the remaining two options, within the second option and third option, if you are going to observe, in the third option we are getting 0 rows for the third query. So it is the right option. We should not consider the second option. So I think with this you got the complete idea regarding. So while at the time of getting like along with the percentage, so all of you please observe, percentage in the sense 0 or many or 1 number of characters. So if the percentage is after the available characters in the sense, so here 0 1 percentage, 0 1 percentage in the sense the starting of the pattern should start with 0 1 followed by any number of characters. It may be 0 or 1 or more. And if the percentage is before the available characters, the meaning of this entire pattern is, so the end of the string should end with 1 4, and before that 1 4 you may consist 0 or 1 or more number of characters. And if the pattern is in the format of percentage, some substring and percentage, so before the substring you may consist 0 or 1 or n number of characters or more number of characters followed by the given substring, and after completion of the substring you may consist 0 or 1 or n number of some other characters. So that means here this is a substring. Before the substring we are having some characters, and as well as after the substring also we are having some other characters. You may consist 0 or 1 or many number of characters. There is no problem at all. For this question the right option is second option. That's all. Now let me try to move on to the next question. So in the next question, so we have one table is there. The table name is member table. So within the member table we are having member ID, name and start date, end date, and as well as the status. So now the query is
how many rows will be returned by the query below. And here the query is select name from member. We need to select the name from the member where name like underscore AR percentage. Underscore AR percentage in the sense underscore means one character, single character followed by AR. So single character. Here the character may be anything. So underscore means any one of the single character followed by AR. So all of you please observe here in the given name, where name like, so the first character is M. Any character will be considered in this underscore. So that here you can consider M and M followed by AR is available. So that this is the right pattern. And as well as if you are going to observe the second one also, any character followed by AR. So it is also considerable. Now till now we are getting two names, and next one is any character followed by AR, but unfortunately here the two characters that are available followed by any character is AI. It is not at all considerable. Next one is any character followed by AR. It is also considerable. And the next one is any character followed by AR, but unfortunately here SH is available. We should not consider it. Any character followed by AR, it is also not at all considerable. Any character followed by lower alphabets AR, not upper alphabets AR, so that we should not consider it. And last one is any character followed by AR in the lowercase letters which are available in the given pattern, so that we should not consider the uppercase characters. Now for this query up to here, the required, the available rows are 1, 2 and as well as 4. Now for this query we have AND operator is available, and for this query we have some extension is available. So we need to satisfy this condition, and as well as we need to satisfy the another condition also. The next column that we are considering here is the status. So the status, that too we need to consider the status in the uppercase characters. And if the status which is in the uppercase character is equivalent to active, so that particular status related row we need to consider. So here out of all the available rows, so 1, 2 and 3, first we need to check the status column is consisting active or not. So unfortunately in the fourth row the status is cancelled, so that we should not consider this row. It is also not at all considerable. And coming to the next one is, so here for the available query, the status, so here the status is ACTIVE active, which is in the format of A capital and remaining all the letters are lowercase. It is in the uppercase. So now try to convert these two strings in the uppercase. That means we are getting active in the uppercase only, so that, so the characters, so the pattern which is matching here is any character followed by AR, any character followed by AR, and as well as the status is in the uppercase. The status is in the uppercase which is equivalent to active. So here we need to consider these two rows. For this particular question, the output that we are going to get here is 2. So out of all the options, the right option is second option. The second option. For this query, we will get two names from the given table. The two names are Mark and Marvin. That's all. With this, I hope you got the complete idea regarding this question. And coming to the next question, so all of you please carefully observe. So the next question is the same table, member table is available. So how many rows will be returned by the query below? Here the query is select a name from the member where the length of the name should be 5. Here consider, all of you please try to count the number of characters in the name. Here the number of characters in the name is 4, we should not consider it. Here the number of characters are more than 5, we should not consider it. Here the number of characters are more than 5, we should not consider it. Here the number of characters are only 5, we need to consider it. Here more than 5, we can simply ignore it. Here the number of characters are only 5, we need to consider it. And the last one is also considerable. Why? Because the number of characters in the given name is, the length of the name is 5. So out of all the 7 rows, we need to concentrate on the 4th row as well as 6th and 7th row. Up to here we need to concentrate on 4th and 6th and as well as 7th. For this same query, we have some extension is also there. We need to satisfy this condition and as well as with the help of AND operator. So we need to satisfy the another condition also. Here the another condition is NVL. NVL stands for null value limit. Null value limit. And that too, that null value limit where we need to apply, we need to apply it upon the end date. So in the end date, the number of rows which are having null values, in that null values we need to replace with the available date. So whatever the date that is available, we need to place it in the end date column, and that too within the end date column, the rows which are having null values, in that null values we need to replace it with 20 April 2015. So that here the updated row content here is, for this particular empty end date we will get 20 April as well as 2015, and as well as, so for the next one also, for this particular row also we will get 20 April APRL as well as 2015, and for this particular row also, for the available column we are trying to update it with the help of NVL function. So the end date column, within the end date column which are having some empty, that means which are having some null values, in that null values we need to replace the null values with the available date April 2015. So here also we need to update it with 20 April 2015. Now here the query is, till now we are just null value limit, with the help of null value limit function in the end date column, the rows which are having null values, in that null values we are replacing it with 20 April 2015. And now we need to subtract it with start date, so that if the subtraction is from the end date to start date, if you are going to subtract the end date with start date, so the whatever the result that we are getting less than 30, we need to consider it. Here if you are going to consider for this particular first row, so 20 April minus start date is 1st Jan. So the value that we are going to get here is nearly 4 months difference is there. Here you will get the value which is more than 30, so that we should not consider this row. First row is cancelled. And coming to the second date, end date minus start date, 20 April minus 1 February. So here itself also nearly 3 months difference is there. The value that we are getting here is from end date minus start date is more than 30 days, so that we should not consider it. So here we need to consider the values which are having lesser value when compared to the 30. Now let me try to take, so just we need to concentrate on the 4th and as well as 6th and 7th rows only. In the 4th row, all of you please observe 15th April minus 1st March. So from 15th April to 1st March nearly 45 days are there, so that we should not consider this row. So 45 days which are greater than 30, not less than 30. That's why we are ignoring this particular 4th row. Now let me try to concentrate on the 6th row. 15th March minus 1st March. Just we are getting 14 days, so that we need to consider it. So 14 days less than 30, it is considerable. And as well as here 20 April minus 1st April. Here also we are getting nearly 19 days. So 19 days are less than 30, so that here it is also a right answer. Now for this query, we will get only 2 rows. So the 2 rows are 6th row and as well as 7th row. And in that 6th row and 7th row, we are getting the names. The names are Edgar and as well as Darcy. These are the outputs that we are going to get. For this question, the right option is, out of all the 4 options, you will get 2 names. The 2 names are Edgar and as well as Darcy. So here the right answer is C option. I hope with this you got the complete idea regarding this question. Now coming to the next question. Again we have the same table, member table. In this member table, select the output from the query below. Here the query is select count of null value limit function is available here. That means, so in the end date column, the rows which are having null values, in that null values we need to replace it with 30 April. So 30 April is available here, 30 April is available here, 30 April is available here, 30 April is available here. In the last row also 30 April is available. So we need to count the all those end date related values from member where the name, like, all of you please observe, wait, the name, like, the starting letter of the name should be capital M, or here logical or operator is available, either this condition or this condition, any one of the condition is true, in the sense you will get that required name. So the starting letter of the name should be M. So please observe, out of all the rows, the names which are having starting with capital M, so the first row, second row, as well as fourth row, or the name, like, end character of the given name is small y. So end character of the given name is small y is available for third row, fifth row. You should not consider seventh row. Why? Because the seventh row last character is capital Y, it is not small y. We need to consider this pattern for the string which is ending with the small y as a last letter, not capital Y as a last letter, so that we should not consider this row. Now here two rows are eliminated. What are the two rows? Last, sixth and seventh row. So we need to concentrate on the first 5 rows only. So in these 5 rows, all of you please observe, we have one more condition is there with the logical AND operator. That means we need to satisfy this condition as well as the available remaining condition. What is the available remaining condition? If the start date is greater than 31st Jan 2015. So all of you please observe, so the start date is, here the start date is 1 Jan 15, which is not at all greater than 31st Jan 15, 31st Jan 15. So we should not consider this row. The next one is, the start date is 1 February 2015, which is greater than 31st Jan 2015. Yes, 1st February is always greater than 31st Jan 2015, so that we can consider this row. Till now we are getting one row. And what is the next one? So the start date is 1st Jan 2015, which is greater than 31st Jan 2015. No, 1st Jan is always less than 31st Jan. We should not consider it. And the next one is 1 March. 1st March 2015 is always greater than 31st Jan 2015, so that we can consider it. March is always greater than Jan, we can consider it. And the last one is 1 Jan 2015. So 1st Jan 2015 always less than 31st Jan 2015, so that we should not consider this row. So till now, out of all the available rows, we are getting only 2 rows. That the 2 rows are second row and as well as third row. And here the count of the end date which is having 30 April 2015 here is 1, 2. So the 2 is the right option among the all the 4 options. Here 2 is available in the third option. This is the right option. I hope with this you got the complete idea regarding this question. Thank you, Ananda. Here in this question we have two tables are available. The first table name is book table and the second table name is book issue table. So in the first table, book table, we have 3 attributes are there: book ID, book name and category. So for all these 3 attributes, try to concentrate on the constraints. So book ID is the primary key in the book table, as well as for the name attribute there is no constraint at all, so that there is no problem at all. You can store the null values in the name also. And here for the category we have one constraint is there. The constraint is check. So in the category, so it has to accept only F or E letters only. So F category or E category only. And coming to the book issue table, so in this book issue table, totally 4 attributes are there: issue date, and the data type of this issue date is date type, and it is a primary key, as well as issue by is one more attribute. Issued by is also primary key in the book issue table. And here the book ID is number type. Here the book ID is acting as like as a foreign key. So the book ID from the book table is acting as like as a foreign key in the book issue table. And we have one more attribute is available. The attribute is status attribute, and it should not be null. Now the question is, which of the following columns allows null values? So from the two tables, if we are going to observe, so in the first table, book ID, it is a primary key. Primary key means it will be unique and it should not be null. So that book ID is not at all acceptable the null values, and we should not consider it. Book ID is not at all acceptable null values in the book table. And for the name, you can accept the null values. Why? Because there is no constraint at all. So in the name attribute, we can store the null values. There is no constraint at all. But out of all the four options, none of the options are having name attribute. So next, consider the category. In the category, we have check constraint is available, and here the flexibility with the check constraint is you can store the values with respect to the available category FRE, or you can store the null value also. In the check constraint related attribute, you can have the flexibility to store the null values. Check constraint will accept the null values also, so that in the book table, in the category attribute, we can have the flexibility to store the null value also. Now out of all the four options, we are going to observe in the book table, in the category attribute, we can have the flexibility to allow null values. So here, out of all the four options, the second option is right option. Now let me try to enter into the next table. In the book issue table, first two attributes are primary key attributes. Primary key attributes are not at all become null, so we should not make primary key attributes as null attributes. So we should not consider these two. Why? Because within that it is not possible to store null values. Now consider the book ID. Book ID is acting as like as a foreign key. In the foreign key constraint, no problem, we can have the flexibility to store the null values. In the foreign key constraint related attribute, we can have the flexibility to store the null values. Now in the book issue table, within the book ID, we can store the null values. Why? Because book ID is having the constraint foreign key. Now out of all the four options in the book issue table, so within the book ID, we can allow the null values. There is no problem at all. It is also right option. And coming to the last one, status is not at all null. So why? Because it has its own constraint. The constraint is it should not become null. And if you are going to consider the last one, so here the last option is in the book issue table, issue date. In the issue date, we should not store null. Why? Because so issue date is a primary key constraint, so that in the primary key we should not store null values. It is not at all correct option. First option is book.book id. In the book table, book id is the primary key constraint. Within that we should not store null values. It is also wrong option. Now out of all the four options, the right options are second and third. In the book table, in the category, so with the check constraint, we can have the flexibility to store the null values also, as well as within the book issue table. So within the book id, it is having foreign key constraint. Within the foreign key constraint, there is no problem, we can store null values. So these two options are right options among the all the four options. Now coming to the next question. So here we have two tables are there, existing state table as well as desired state table. Here the question is, identify the minimum number of operations required to reach the desired state from the existing state to for the desired state. So how many operations that we need to perform? So here you can easily observe in the existing table totally we have 5 rows only, but in the desired table we have totally 6 rows are there. That means definitely there is one insertion is available. Now if you're going to observe out of all the four options, so in the first option we have one insert option, and second option also we are having one insert. In the third option also we have one insert. In the fourth option also we are having two inserts. So no, it is not at all possible to perform two insertion operations from the existing state to the desired state. The reason is, so here the thing is, in the existing state 5 rows are available, and in the desired state we have 6 rows are available. It is possible to store one row in order to move to the desired state from the available existing state. So we can eliminate the last option. And coming to the first three options, now out of all these three options we need to choose the right option. So in order to choose the right option, all of you please observe. So now in the first table, so we have head first SQL is the name. For this, the category is educational. So head first SQL is available in the desired table also, and its category is educational only. There is no change in the first row. Coming to the next one, to kill a mockingbird is the name, and the category is fiction. Whether the same row is available in the desired state or not, try to check it. Yes, in the desired state, to kill a mockingbird, and the category is fiction. There is no change at all in the second row also. What about the third row? Head first Python, and the category is educational. Head first Python is available and the category is educational. There is no change in the third row also. But if we are going to consider Banaras, city of light, here the category is travel. Here Banaras, city of light, but the category is tour. That means there is one updation with respect to the given category. Instead of travel, here the updation is tour. That means one updation is happen here. And as well as so here one updation is there. And coming to the next one, a guide to Goa, and the category is travel. A guide to Goa is available, but here the category is tour. That means here one more updation is happening. So here one updation, here also one more updation. Totally two updations are available. Two updations are available. And what about this row in the desired state? Actually, this row is not at all available in the existing state. It is the new row that was inserted from the existing state into the desired state. So that here the insertions, the number of insertions are one insertion is there, and as well as two updates are available. The one inserted new row is at first JavaScript, and the category is computer, and the two updations are instead of travel category in the Banaras, city of light, and as well as a guide to Goa, instead of travel, so here the updated table, within the updated table we are having the category 2. So here two updations are there, one insertion is there. Now out of all the four options we are going to observe, so one insertion is available here and two updates are available in this particular second option. Out of all the four options, the right option is second option. First option is wrong, third option is wrong, fourth option is wrong. That's all. Coming to the next question, so we have one person table is there. This is the table structure. Within the table, ID, name of the person, age of the person, city. Here we have some constraints are there upon the person table. The constraint is ID is having primary key constraint, and the name is having unique constraint. In the unique constraint we have the flexibility to store the null values also. There is no problem. Only in the primary key it is not possible to store null values, please remember it. And as well as in the age attribute also, so it has the constraint check in the sense, so while at the time of storing the age is in between 10 to 40 years only, so we need to consider the value in between the range of 10 to 40 only, or otherwise we can store the null value in the check also. So in the age attribute we can store the null value also. Why? Because in the check constraint there is no problem of storing the null values. You can have the flexibility to store null value, or we need to provide the value in between the range of 10 to 40. And city is comes under the category of not null category. Definitely, while at the time of inserting the number of rows into the personal table, definitely for the city we need to provide the value. For the city we need to provide the value, as well as for the ID. For the ID also we need to provide the value, and the remaining two are optional. So for the name and age we can provide null values, or if you want to provide the value for the name, all the names should be unique. And for the age we need to provide null value, or if you want to provide the value should be range in between 10 to 40. Now which of the following insert queries will execute successfully? Now try to observe what is the first query. Insert into person ID name is. So here it is not possible to, so here we are not at all storing the city, person related city in this query. So but the city is not null, so that we should not consider this first query. Why? Because in the insert query definitely the city should be the mandatory attribute, but unfortunately in the first query we are not at all inserting the city related details. Coming to the second query, insert into person of id, name, age and city, and the values are id value is 6, no problem, and the name value is, so here the question mark with the one simple symbol is available, we need to consider it as double quotes. So the question mark symbol we need to consider it as a single quotes, so we need to consider it as a string. So name is of the type of varchar and we are trying to store some string value, there is no problem at all. Coming to the age, so age has some check constraint is available. Before going to store the age should be in between 10 to 40 or null value. So here, but unfortunately we are trying to store 50. 50 is not at all possible to store in the age attribute. Why? Because age has some check constraint, within that we can store 10 to 40 value only. It is not possible to store 50. So we should not consider this second query also in order to insert the data into the available table. Now what about the third query? Insert into person. So id is the mandatory field and age for the number, no problem. So number has unique constraint and you can provide the unique in the name, it has unique constraint. So within that name you can provide unique name or we can make it as null. So here I am not at all storing the name, there is no problem at all. In the unique constraint we have the flexibility to store the null values also. And coming to the age, here the age that I am storing here is 40, no problem. 40 is in the range of 10 to 40, and as well as the city is also mandatory field. id is the mandatory field, city is the mandatory field, and for upon the age we have check constraint is available. As per the given check constraint we are storing 40 and it is in the range of 10 to 40, so that it is the acceptable query. So and the city name is varchar, that means we need to provide the city name in the format of string. So here just consider these two question marks are acting as like as a single quotes. So this is the right option. What about the last option? Insert into person id, name, age, city. All the four values we are trying to store into the given person table. So here the id is 8, it is the unique value, as well as the person name in the single quotes, consider them as a single quotes, and the age is 10. 10 is in the range of 10 to 40, there is no problem at all. As per the given check constraint it is valid, and the city of the person is London, it is also acceptable. So this is also right answer. Out of all the four options, the right options are 3 and 4. And coming to the next question, so let me try to go to the next question. So here in the next question, given the data provided below, choose the most suitable primary key. So as we already knew that primary key means we need to uniquely retrieve the particular record from the given table. There is no duplicates in the records. Now with the help of what is the best suitable primary key in order to identify the unique record from the available table. Now what is the first combination? If you are going to combine the multiple attributes, first name, last name and age. So with the combination of first name, last name and age, is it possible to retrieve the unique record? Try to observe. So for example, if you are going to consider first name, last name and age, here the first name Jack, last name is Brown, and as well as the age is 22. The same first name Jack, Brown, here the age is different, 20. That means there is no duplication at all till now. There is no duplication at all in the two rows. So Jack Smith 20. Here also there is no duplication among the all the three records. Why? Because we have the age difference in between, second row and third row. Why? Because first name and last names are same, but there is a difference in the age. These two are two different records. Up to here no problem. And coming to the first row and as well as third row, first name and age is same, but there is a name difference in between last name. Up to here we are retrieving the unique records, there is no problem. What about the next one? So Jeff Brown 20, it is also unique record. Jeff White 22, it is also unique record. Now the last record is John Brown 20. Already we have John Brown 20. John Brown 20 records are available here. Please try to observe. So within the third row we are getting John Brown 20, and the same duplicate record is available in the last row also with the combination of first name, last name, and as well as age. John Brown and as well as 20. So with the combination of first name, last name, and age, it is not possible to retrieve the unique record. We are having duplication. So two duplications are there. 1, 2. Next one, last name, age, place of birth. Now let me try to consider last name, place, age, place of birth. So with the combination of last name, age, place of birth. So here Brown 20, London, Brown 20, Liverpool, Brown 20, Liverpool. So here also we are getting the duplication with last name, age, and place of birth. So here the last name which is having Brown and the age is 20 and as well as the place of birth is Liverpool, that the same record is appearing more than one time. Brown 20, Liverpool. So that it is not at all possible to retrieve the unique record with the combination of last name, age, and place of birth. We are getting duplicate records. So that we should not consider it as a primary key combination. First one is wrong and second one is wrong. Now let me try to consider the third option. What is the third option? So the third option is first name, last name, place of birth. So first name, last name, and place of birth combination. So the first name, last name with place of birth combination. Jack is the first name, Brown is the last name, London is the place of birth. John, Jack, Brown, London. Here we are getting the duplicate records. So first name, last name, place of birth is same in the two records, so that we should not consider it as a primary key combination. So third option is also wrong. Till now we are getting first three options are wrong options. What about the last one? First name, last name, age, place of birth. With the combination of first name, last name, age, and place of birth, try to observe. So let me try to take another color. Jack Smith 20, London, unique record. Jack Brown 22, London, unique record. Jack Brown, but there is a age difference 22, here 20, London. Up to in the all the four fields, in the all the four columns, first name, last name, place of birth is same, but there is a difference in between age. That means these two are unique rows, so no problem. And Jeff Brown 20, Liverpool, unique record. Jeff White 22, Liverpool, unique record. Jack Brown 20, Liverpool, it is also unique record. So now with the combination of first name, last name, and age as well as place of birth, you can choose the primary key, so that you can retrieve the unique record from the available table without having any duplication. Now out of all the four options, the right option is last option. I hope with this you got the complete idea. Thank you. Here in this given question, the table name is payment table. So now the question is, how many rows will be returned by the given query? The query is select location comma count of payment ID from the payment table where the amount is greater than 40. And here the group by clause is there. By grouping location and payment mode, we need to identify the amount which is greater than 40. Now here the group by clause is available upon the location and as well as payment mode. Now try to observe the combination of payment mode and location. Here the cash house done. This is the first combination. Try to check the same combination is available one more time. Yes, here it is available. It is also comes under the first group. So now the first group, so the first group is cash was done, and as well as the second group is, so try to consider credit card is the payment mode and New York is the location. So this is comes under the second group. Try to check whether it is occurring more than one time or not. Yes, here also credit card and New York is available. It is also comes under the second group. In the last row also it is available. It is also comes under the second group. Now what about the next combination? Debit card and Chicago. So with the combination of payment mode, location, debit card and Chicago, we can form the third group. Try to check whether it is available one more time or not. Yes, it is available one more time. Debit card and Chicago, it is also comes under the category of third group. Now the fourth one is online banking New York. So let me try to consider it as a fourth group. Try to check whether it is available one more time or not. Yes, it is available. So it is also comes under the category of fourth group. And the fifth group is credit card Hostan. So it is not at all available at any way. It is special group. It is the fifth group itself. And the sixth group is credit card Phoenix. So this is the sixth group. And the last group is debit card Boston. Now totally 7 groups are there with the combination of payment mode and location. Now as per the given groups, try to check it. In the given groups, so the amount which is greater than 40. So in the first group, if you are going to check it, the first group itself is, so let me try to take different colors. So the first group amount is 80, and here also it is comes under the category of first group. So the amount is greater than 40, so that we can consider it as a one record. So first group we can take it as a one record. So one row will be retrieved. And what about the second group? The second group is, so 40, 20, 50. So let me try to take different colors. So in the second group the amount is 40, which is not at all greater than 40. Try to check the another one. Here the amount is 20. 20 is also not at all greater than 40. But here in the second group the amount is available which is greater than 40, that is 50. So we can consider the second group also. Now the entire second group we can consider it as a, so one more record. So second group we can take it as a one more record. Till now we are retrieving 2 records. So what about the third group? So as per the given third group is having amount 40, which is not at all greater than 40. And try to check one more time, the third group is available here also we are having 40. So that in the third group none of the record is having the amount more than 40, so that we should not consider the third group. We need to eliminate the third group. Now what about the fourth group? In the fourth group, if you are going to consider, so in the fourth group itself the amount is 60, which is greater than 40, we can consider the fourth group. So here, so in the fourth group we are having the amount less than 40, no problem. Out of the fourth group available, from the available elements, so 60 is available here, so that we can consider it as a one group. Now in the fourth group, so from this fourth group you can retrieve the record. So 3 rows are coming. Why? Because in the first group we are getting this entire first group is collectively forming one record, and the record is with the combination of cash Hostan. Here also cash Hostan. It is comes under the category of one record. And coming to the second group, in the second group, so here in the last record the amount is greater than 40, so that we can consider it and we can retrieve as a record. And in the third group none of the amount is greater than 40, so that we should not consider the third group. Next, coming to the fourth group, in the fourth group itself, so the amount is greater than 60, so that we can consider it as a new record. So totally till now we have successfully retrieved 3 records. And what about the next one, fifth group? Try to consider the fifth group. So within the fifth group the amount is greater than 40, so that we can retrieve it. So it is retrieving in the format of fourth record. What about the next sixth group? Try to check it in the sixth group if you are going to check it. So in the sixth group the amount is 60, which is greater than 40. We can retrieve this as a record. So this is fifth record from the given table. Now what about the last group, seventh group? In the seventh group the amount is 10, which is not at all greater than 40, so that it is not possible to retrieve the seventh group. So out of all the 7 groups we have eliminated the third group and seventh group, and the remaining all the groups, first group, second group, fourth group, fifth group and sixth group. So from that all the groups totally we are retrieving, so 1 2 3 4 5. 5 records. Now for this entire question, the answer is out of all the 4 options, 5 is the right option. Why? Because so by group together, location and payment mode, by group together, totally we have formed 7 groups. Out of the 7 groups, group 3 amount is less than 40. In the group 3, none of the record is having amount is greater than 40, so that we are eliminating group 3. And as well as in the group 7 also, none of the record is having amount greater than 40, that's why we are eliminating group 7 also. And from the remaining all the groups, in the group 1, so the amount is greater than 70, we are considering amount is greater than 40, we are considering. In the group 2 also, so the amount is greater than 40, we are considering. In the group 4 also, in the group 4 itself, the amount is greater than 40, that's why we are considering. And in the group 5 also, the amount is greater than 40, and in the group 6 also, the amount is greater than 40. So any one of the record which is having more than the amount 40, we can consider that group. So now out of all the groups, the right option is 5. Why? Because we are retrieving 5 records successfully. And coming to the next question. So the next question is, we have payment table is available, and the query is find out the output of the following query. The query is select payment mode from payment group by payment mode having the average amount which is less than. Here we have one more query is there. Totally 2 queries are there. So what are the 2 queries? One is left hand side for the less than, and the another one is right hand side of the less than. So try to evaluate this query first. Now what is the answer from this query? Try to check it. So in order to evaluate it, try to check it. Select max of average of the amount from the payment group by the location. Now try to identify the number of groups based upon the location. So number of groups based upon the location. So especially with respect to the location, Hostan is the first group. 1. Here also it is also comes under the first group. It is also comes under the first group. Totally Hostan is occurring 3 times. That's why these 3 are comes under the one group. Next, New York. Let me try to take another color. It is the second group as per the location. It is also second group as per the location New York. It is also comes under the second group. So the last record also comes under the second group. And let me try to take the Chicago as a third group. As per the Chicago, it is the third group. Let me try to consider Chicago as a third group. And next, Phoenix is the another group. So Phoenix is the fourth group, and Boston is the fifth group. Totally we are getting 5 groups based upon the locations. What is the first group? Houston is the first group. In the Houston totally, so 3 records are available. So 1, 2, 3. And in the New York is comes under the second group as per the location New York. So 1, 2, 3, 4, 5 records are available. And as per the Chicago, we are getting 1, 2 records. 2 records are comes under the category of Chicago group. And the next one is Phoenix is the only one record which is comes under the fourth group. Boston is the another record which is comes under the fifth group. Now what we have to do now? For each and every group, we need to calculate the average of the given amounts. Now let us assume in the first group totally, so the amounts, let me try to take the amounts in the first group. So the amount in the first group is 80 here, and here 70, here 60, and the total summation of the 3 amounts are 80 plus 70, 150 plus 60, 210. So 210 by, in order to calculate the average, the summation of the all the amounts by the total number of amounts. So 210 by 3. 210 by 3 in the sense we are getting 70. So 70 is the amount that we are getting for the first group. For the first group we are getting 70 is the average amount. What about the second group? Let me try to take the second group related amount. So 40 here, 60 here, 20 here. In the second group, 30 is available here, 50 is available here. So second group is occurring 1, 2, 3, 4, 5, 5 times. Now calculate the summation of all the amounts in the second group. 40 plus 60, 100, 100 plus 20, 120, 120 plus 30, 150, 150 plus 50, 200. 200 by the total number of elements in the second group. 1, 2, 3, 4, 5. 200 by 5 in the sense. So you will get 40. So for the second group, the average amount that we are getting is 40. Next, so we need to calculate the average amount of the third group. So as for the given third group, so 40 is here, 40 is here, and the third group is occurring only 2 times, so that the summation of the third group elements are 40 plus 40, 80. 80 by 2 is the average. 80 by 2 in the sense we are getting 40 only. Now for the third group also we are getting 40. 40 is the answer that we are getting for the third group. Next, what about the fourth group? In the fourth group only one element is available, and that is the average amount. So for the fourth group we are getting 60. And what about the fifth group? In the fifth group we are getting the average amount is, so for the fifth group the average amount is only one element is available, that is the average 10. Now out of all the groups we are getting the average amount, and among the all the average amounts we need to calculate the maximum of the average amount. What is the maximum of the all the average amounts? So 70 is the maximum of the all the average amounts. So that's why we need to consider that value. So here you will get 70. 70 is the value that we are getting for this particular entire query. Select max of average amount from the payment group by the location. For this entire query, the answer that we are getting is 70. Now let me try to evaluate the left hand side of the relationship operator. So select payment mode from the payment, group by the payment mode, group by the payment mode. So payment mode, as per the payment mode, we need to group the elements. So totally how many payment modes are there? Here we need to concentrate on the payment modes. Now as per the payment modes, carefully observe. Cash is comes under the first group. Cash is comes under the first group. Credit card is comes under the second group. Now cash is comes under the first group. Credit card is comes under the second group. Credit card, where is the credit card? Yes, here, here, here. Here also credit card is available. Credit card is occurring 1, 2, 3, 4, 5 times. Cash is occurring only 1 time, 2 times. Debit card is comes under the third group. 1, 2, 3. Debit card is occurring 3 times. So for that, let me try to take different colors. No problem. While at the time of taking the amounts, I will take different colors. Now online banking, it is comes under the fourth group. So it is occurring here, and in the 8th row also it is available. Now totally 4 groups are there as per the payment mode. Now we need to calculate the average amount for the available payment groups. Now what is the first group? Can you please observe? Cash. Cash is the first group. As per the cash, let me try to this color. The amount is 80, 70. 80 plus 70. 80 plus 70 in the sense you will get 150. 150 by 2 in the sense you will get 75. So 75 is the answer that we are getting. 75 is not at all less than 70. 75 is not at all less than 70. So that we can eliminate the cash group. So we can eliminate the cash group. Now out of all the four options, so in which option we are having cash, we can eliminate it. So cash is not at all comes into the picture in the output. So we can eliminate the first option as well as we can eliminate the second option also. Now the right answer is among the third and fourth options only. Now try to take the second group. What is the second group? Credit card. So now for the second group, let me try to take another color. So second group related amount is 40, 20, 60, 60, 50. So second group is occurring 1, 2, 3, 4, 5. 5 times. Now try to calculate the average of all these 5 elements. 40 plus 20, 60, 60 plus 60, 120, 120 plus 60, 180, 180 plus 50. So we are getting nearly 230. 235, 1, 2, 3, 4, 5. 5 elements. 230 by 5 in the sense definitely you will get. So 46 I think. So 5 20s are 5 4s are 20, 5 6 are 30. 46 is the answer that we are getting. Now the 46 is the answer that we are getting here, which is always less than 70. So 46 is always less than 70. That means credit card will be one of the option in the given payment modes. Now try to check it where the credit card option is available. So the credit card option is available in the third option. It is not at all available in the fourth option, so that we can eliminate the fourth option also. Now out of all the 4 options, the right option is third option. Let us try to check it. Till now we are getting credit card value. So the average amount of the credit card payment value is 46, which is less than 70. Now let me try to take the remaining 2 methodologies also. Debit card. Now debit card is occurring. Let me try to take another color. So debit card 1, 2, 3. So it is occurring 3 times. Try to check it. 1, 2, 3. Now try to calculate the debit card related amount. 40 plus 40, 80, 80 plus 10, 90. 90 by 3 in the sense for this debit card payment mode, 90 by 3 in the sense the average that we are getting is 30. So 30 is always less than 70. So that debit card is also one of the option in the output table. So debit card is available in the third option, so that there is no problem. Definitely the third option is the right option. Try to check it for the online banking. Now the what is the fourth payment mode group? Online banking only. So now the fourth payment group is available 1, 2. Only 2 times it is available in the given payment modes. Now as per the 2 times, try to calculate the average. So 60 plus 30. 60 plus 30 in the sense you will get 90. 90 by 2. So 2 elements are available. 90 by 2 in the sense we are getting 45. For the payment mode online banking, we are getting the value 45. 45 is always less than 70, so that you will get the online banking is as a output in the output table. Now the online banking is also available in the third option. Now out of all the 3 options, out of all the 4 options, the right option is third option. So very careful while at the time of getting these kind of questions. So we need to group them properly and we need to identify the answers properly. So with this, I hope you got the complete idea regarding the given question. Thank you. Here in this question, we have one table is there. The table name itself is payment table. Now the query is, so what will the output of the following query? The query is select location comma count of payment ID as count from payment where, so with the help of toChar function for the payment date we are retrieving the month. We are retrieving the month name. Here the month names are Jan, Feb, March, like that we are having month names. So we can retrieve the month name from the payment ID with the help of toChar function, and if the month name is equivalent to Jan, so at that time we need to group by with the location. With the help of location we need to group by all the records, and we need to identify the location which is having the month name is John, and having the sum amount is, so you will get some sum amount which is equivalent to some other query is available. So here for the equal to, we have left hand side is there, right hand side is there. Now let me try to analyze the right hand side query first. Now what is the right hand side query? All of you please observe. Select max of sum of the amount from the payment table, where with the help of toChar function we are retrieving the month name from the payment date, and if the month name is equivalent to John, and that too with the help of group by function, group by, so we are trying to group the all the locations. So first we need to group all the locations, try to apply the group by clause in order to group all the locations. Now here totally, let me try to take the groups. So Houston is the first group. How many times it is occurring? 1, 2, and as well as here also it is available. It is occurring 3 times. Now the second group is New York. As per the location, try to check how many times it is occurring. So it is also comes under the second group. Here also it is comes under the second group. New York is occurring more than nearly 1, 2, 3, 4, 5. It is occurring 5 times. What about the Chicago? Let me try to take the Chicago location. It is occurring 1 time and second time. Total it is occurring 2 times. Now the remaining locations are Phoenix. It is only occurring only 1 time. So it is the fourth group, and the last group is Boston. So totally 5 groups are there as per the locations. The first group is Houston, second group is New York, and the third group is Chicago, and the fourth group is Phoenix, and the last group is Boston. Now group by location completed. Totally we are getting 5 groups. Now here what is the query? Try to evaluate it. So we need to calculate the sum of the amount from the each and every group, where, so the condition is the month of the each and every, the month of the each and every payment date is equivalent to Jan. Try to check it in the first group. If you are going to consider the first group, so in the first group what are the dates that are available? So we are getting 2 dates. Why? Because the first group, in the first group we are getting 2 records. In these 2 records, try to check the month name. If the month name is equivalent to John, so actually the first group is occurring more than 2 times. It is occurring 3 times. Now try to check it. So totally 3 payments dates are there with respect to the first group. Now out of all the 3 payment dates, try to check in which payment date the month is equivalent to Jan. So in the first payment date the month is equivalent to Jan, you can consider it. In the second payment date the month is not at all equivalent to Jan, so we should not consider it. Try to ignore it. And in the third payment date with respect to the first group, the month name is Jan, we can consider it. Now as per the month name is Jan, we are getting 2 amounts, so we need to omit it. We need to ignore the month name February. Why? Because in the where condition, from the payment date we need to consider the month which is equivalent to Jan. So here the month is February, that's why we are ignoring it. Now as per the first group, just we are getting 2 records which are having the month name which is matching with the January. Now try to calculate the sum of the amount. What is the sum of the amount? 80 plus 60. 80 plus 60 in the sense you will get 140. Now for the first group, the sum of the amount that we are getting is 40 as per the given where condition, where the payment date related month is equivalent to Jan. Yes, the payment month is equivalent to Jan. In that month equivalent to Jan, the amount is 80 and 60. So the total amount is 140. Now coming to the second group. So in the second group also, try to identify what are the dates that are available for the second group. So here 1, 2, 3, 4, 5. Totally 5 dates are there. Why? Because second group is occurring 5 times. Now in these 5 dates, try to check it. In which month we are having the month name is Jan. So here Jan is available here. You can consider it. Next, February is available here. We should not consider it. Why? Because in the where class, the month is not at all equivalent to Jan, so we need to ignore it. Next, here we are getting March, we need to ignore it. Next, here also we are getting March, we need to ignore it. And in the last record, which is belonging to second group, the month name is equivalent to Jan, so that we can consider it. Now in the second group, the total summation of the amount is 40 and 50 with respect to the month name is Jan. Now 40 plus 50, we are getting 90. 90 is the value for the second group, the summation of the month. So the summation of the amount is 90. Now try to consider the third group. So in the third group, we are getting two dates, and the two dates are having the month name Jan, so that the summation of the two dates are 40 plus 40, 40 plus 40, 80. For the third month, the sum of the amount is 80. What about the fourth month? So what about the fourth group? In the fourth group, so we are having only one record. In that record, the month name is Jan, we need to consider it. So here we are getting 60. For the fourth group, we are getting 60. And for the fifth group, only one record is available, and but unfortunately in that record the month name is not at all equivalent to Jan, we need to ignore it. Now totally 4 groups are having some amount, and out of all the 4 groups we need to identify the maximum sum amount. So the maximum sum amount for the group is first group. Now here the maximum sum amount is 140. Up to here, after completion of the successful evaluation of the right hand side query, we are getting 140 is the result. Till now for this query we are getting 140 is the result. Now try to evaluate the left hand side query. So what is the left hand side query? Select the location. We need to identify the location, comma, count of payment ID. We need to count the payment IDs as a count from the payment, where so toChar, with the help of toChar function, from the payment ID, if the month name is equivalent to Jan, we need to consider it. And here also we are using group by class. So with the help of group by location itself only. So with the help of location itself only. So which is having the sum amount is equivalent to the right hand side query. As we already knew that, so the sum amount which is equivalent to right hand side query, which we are getting in the location Houston. Try to check it now. So try to calculate it. So group by location, the first location itself is Houston. So in the Houston, so we are getting 3 dates: Jan, 1st Jan 15, 15th February 15th, 31st Jan 15th. So we need to ignore 15th February 15th. Why? Because here the month name is February and we need to match it with Jan. It is not at all matching. That's why we are ignoring it. Now try to calculate the sum amount from this available two dates in the first group. So 80 plus 60. 80 plus 60 in the sense you will get 140. So the 140 amount is equivalent to the right hand side query. So that here the location name that we are going to get here is Ostan, and as well as try to count the payment IDs. So the payment IDs are, we are getting 1, and as well as for this particular date we are getting 2. Totally 2 payments IDs are there with respect to the location Houston. So with respect to these 2 payment IDs only, we are getting the summation of the amount 80 plus 60, 140, which is equivalent to the right hand side query. So that's why now for this question, so we need to identify the location Houston with the count is, the payment ID count is 2. So with respect to the 2 payment ID dates only, we are calculating the summation, and which is equivalent to the right hand side query. Now out of all the 4 options, the right option is first option. That's it. Now let me try to go to the next question. So in the next question, so we have the payment table is available, and here the query is we need average payment amount for each payment mode. So for each payment mode, we need to find out the average payment amount. We need to find out the average payment amount for each payment mode that have average payment mode more than 45 sorted by the average payment amount so that the largest payment amount appears first. So largest amount payment is appeared first, in the sense we need to order it by descending order. Within the descending order only we will get the largest element first, and the remaining all the elements are occurring one by one. So definitely ordered by the descending we need to use it in order to get the largest payment occurring first. So which of the following queries meets the requirement? So totally 4 queries are there. So in that all the 4 queries we need to identify the right query. So just read the question one more time. We need average payment amount for each payment mode. First, what is the each payment mode? Totally how many payment modes are there? Payment modes are, so try to consider. So 1. So this is one payment mode. Next, credit card is the another payment mode. 2, 2, 2, 2. It is nearly occurring more than 1, 2, 3, 4, 5. It is occurring nearly 5 times. Debit card is the another payment mode. Third group, 1, 2, 3. It is occurring 3 times. Online banking is the fourth payment mode. It is occurring 2 times. Now we need average payment amount for each payment mode. Average payment amount for each payment mode, in the sense, so first we need to calculate the average amount for the each payment mode. For the first payment, let me try to take the color. So 80 plus 70, 80 plus 70, 150, 150 by 2, in the sense you will get 75 is the average amount. And as well as, so that means for the first group we are getting 75 is the average amount. For the second group, let me try to take another color. 40, 20, 60, 60, 50. Try to calculate the summation of all the elements. 40 plus 20, 60, 60 plus 60, 120, 120 plus 60, 180 plus 50, 250, 230. 230 by 1, 2, 3, 4, 5, 5 elements. So 230 by 5, in the sense nearly you will get 46. Now the second group, as per the second group credit card, so we are getting the average amount is 46. What about the third group? So the third group is debit card. With respect to the debit card, so 1, 2, 3, it is occurring 3 times. 1, 2, 3. Now 40 plus 40, 80, 80 plus 10, 90, 90 by 3, in the sense 3 times it is occurring, 90 by 3 in the sense 30. For the third group we are getting the average amount is 30. Next, what about the fourth group? Fourth group is occurring 1, 60, 2, 30. So 60 plus 30, again we are getting 40 only. Fourth group is occurring only 1, 2 times only. So 60 plus 30, 90, 90 by 2, in the sense you will get 45. Fourth group we are getting 45. Now these are the average amounts that we are getting with respect to the each and every payment mode. Now the next one is that have average payment amount more than 45. So that have average amount more than 45 sorted by average payment amount so that the largest payment amount appears first. So here we need to sort them in the descending order. Which of the following queries meet the requirement? Very simple. Here all of you please observe. So we need to have the order by descending order. In which option we are having order by descending order? So in the first option we are having order by descending order. In the third option we are having order by descending order. So remaining two options we can ignore them. Why? Because the reason is So here we need to print the largest amount first. So after that we need to get the remaining all the amounts. That means we need to print the elements in the decreasing order. For the decreasing order, we need to consider ordered by decreasing, ordered by decreasing. But here, out of all the four options, already we have eliminated second option and as well as fourth option. Now try to identify the right option from the 1 and 3. In the 1, so ordered by average descending. So try to read the statements carefully. Select payment mode, comma, average amount from payment where average amount greater than 45, group by payment mode ordered by. So no, there is no proper order in the query. Try to read the third query. Select payment mode, comma, average amount from the payment, group by payment mode, having the average amount greater than 45, ordered by average amount in the descending order. Now C is the right option in order to convert this entire theory into the query. So C is the right option. So try to read it one more time so that you will get the clarity. Select payment mode, comma, average amount from the payment, group by payment mode, having the average amount which is greater than 45, and we need to print it ordered by average amount in the descending order. So the right option is C option. I hope with this you got the complete idea. Thank you Ananda. Now here in this question we have payment table is available. Here the question is how many rows will be produced by the query below. So here the query is select distinct payment mode. So out of the all the available rows we need to identify the distinct rows according to the payment mode, comma, location. And here with the help of case, the case is with respect to the given amount, and the case is when the amount is 20 then we need to multiply it with 2. When the amount is 40 then we need to add 10 to the available amount, else we need to take the amount is 40. Apart from the first two conditions, so if the amount is greater than less than 20 or which is greater than 40, we need to consider the amount number itself is 40. So we need to do all these things from the payment table where the location is not at all equivalent to Chicago. Let me try to read the query one more time. Select distinct payment mode, comma, location as per the given case. What is the case? When the amount is 20 then amount equal to amount into 2. You need to multiply the amount with 2 when the amount is 20. So here we are going to consider so many conditions. Out of all these conditions, here the amount is 20 in the sense we need to multiply it with 2. If the amount is 40 then add 10 to the available amount. So if the amount is 40, just add 10 to the available amount. 40 plus 10 in the sense it will become 50, or else simply consider the amount number itself as 40. So for the 60 we need to take it as in the format of 40 only. Why? Because it is not at all equivalent to 20 or it is not at all equivalent to 40. Due to that reason we need to take it in the format of 40 in the else case. So from the payment table only we need to do all these operations. Now here the condition where when the location is not at all equivalent to Chicago. So when the location is not at all equivalent to Chicago, in a sense we need to simply eliminate the last row. Why? Because the last row related location is Chicago. That's why we are eliminating this row. Now out of the available all 6 rows, so we need to perform this case statement. Now try to perform it. So here the statement itself is when the amount is 20 then only we need to multiply it 2, or when the amount is 40 then only we need to add 10, otherwise we need to consider 40. So now the what is the first amount? 60. For the 60 we need to consider the amount is 40 and the payment mode is cash and the location is Houston. This is the first row that we are getting. What about the next one? If the amount is 20, then only we need to multiply it 2, or if the amount is 40, then only we need to add 10, otherwise we need to take 40. The amount is 60, just try to take it as 40. And here the payment mode is credit card. CC stands for credit card and the location is New York. This is the second row that we are getting. If the amount is 40, then what we need to do, we need to add 10. So 40 plus 10, in the sense it will become 50, and here the payment mode is cash and the location is Austin. So please remember it. So here just we are adding 50, the region is we are adding 10. The region is whenever the amount is equivalent to 40, we need to add 10. Now the next row, so the amount is 40, so that we need to add 10, so it will become 50, and the payment mode will become credit card and the location is Austin. And when the payment amount is 20, then what we need to do, we need to multiply it 2. So 20 into 2, it will become 40, and the payment mode is credit card and the location is New York. When the payment amount is 20, try to multiply it 2, so that it will become 40, and the payment mode is cash and the location is Austin. So totally how many records we are getting? 1, 2, 3, 4, 5, 6. But out of all these records, we need to select distinct payment mode, comma location. So payment mode as well as location should be distinct. Try to check it. So here the payment mode C is available and the location is Austin is available and the amount is 40. It is occurring more than one time. Try to check it. In the last row, the payment amount is 40, the mode is cash only, and the location is Austin. So we are getting duplications. Out of these duplications, we are getting distinct values. That means we need to ignore one row. Out of the two available rows, we need to consider the distinct value, only one value. So just we are ignoring the duplicate value. So that means till now we are getting only one row. Next 40 credit card New York. The same row is occurring one more time. Try to observe. Here also we are getting 40 credit card and New York. But the thing is we need to get the distinct payment mode. We don't want to consider the duplicate payment mode. Due to that reason, let me try to ignore the one more row with respect to the credit card. Why? Because it is already available in the previous row. So till now we are getting two rows. What about the third row? So cash with a different amount 50 and the location is Houston. So it is a unique record. So credit card, the previous credit card amount is 40 here, but the new amount is 50, so that it is a new unique record. So with respect to the cash, two amounts are available, 40, 50. Even though the location is same, here the amounts are different, so that these two are two different records. As well as with respect to the credit card also, so the locations are different as well as the amounts are also different. So totally we are getting 4 unique records from the available query. So out of all the 4 options, the right option is 4. We will retrieve 4 unique records from the available data. So option C is the right option. Now let me try to go to the next question. So here the next question is the combination of, so here the applications are available and the respective database available in the right side. We need to match the following. For this, so it is the theoretical question. All of you please observe it. So for financial data needs the transaction support and data is in the format of fixed structure. For that we need to consider a relational database. Please remember it. So especially if you want to perform transaction related operations as well as the data is in the format of fixed structure, we need to consider relational database. And next one is product catalog, heavy volume of reads and infrequent writes. Data has dynamic structure. If the data is in the dynamic structure and that too, if you want to perform different type of read write operations upon the heavy volume of the data. So it is always better to take it in the format of document oriented database. Next, recommendations need repeat traversal of links between customers and ratings. For this, it is always preferred to consider graph database. Use user activity logs, heavy volume of writes. If you want to do this type of operations, it is always better to consider column family store. Shopping cart, temporary information that is frequently changed. For this, it is always better to take key value store. So it is a theoretical question, just so as per the given circumstances, what kind of database that we need to use. Please try to read it 1 or 2 times so that you will get the complete idea. Coming to the next question. So here the question is, we have one person table is there. In the person table, so the query is select name from the person. We need to select the name of the persons ordered by age in the descending order. Descending in the sense higher age to lower age, comma city. Ordered by age in the descending order, comma city in the chronological order. City is in the ascending to descending. So city is in the format of ascending order, age in the format of descending order. So try to apply it carefully. Now from the available table, if you are going to apply age in the descending order and city is in the chronological order, the first person name that we are going to get here is, out of all the ages, the highest age is 23. Why? Because age in the descending order, the topmost age will be coming into the topmost record, highest age will be coming into the first record. So Jack Brown 23 live pool is the first record. And coming to the second record, so we are having next age is 22. But here the thing is, with respect to the 22, we need to consider the city chronological order. In the city, the first letter is LL and the second letter is, both are matching, so that we need to check the second letters. In the second letters, I is coming before when compared to the both. That's why we need to consider this record as a second record. So for the city, we need to follow ascending order. So ascending order in the sense, first we need to try to take it as a first record. So Jack White 22 Liverpool will come first when compared to the Jane Brown 22 London. The reason is both the records are having same age 22. Here we are comparing the records and we are considering the records based upon the chronological order of the letters. LL same, but I will come first. That's why I am considering the Jack Wright record as a second record. And the next immediate record will be definitely, so Jane Brown 22 London. Now what about the remaining records? Till now we have successfully completed 3 records. Now what about the next 3 records? So in the next 3 records we are getting the same as 20 20 20. Now whenever we are getting the problem with the age, if the age is same, try to consider the city locations. Now the city locations, in the city locations also, so out of all the 3 city locations, we are getting LI is first when compared to the LO. That's why out of the all the records, we need to take the Thomas Smith 20 Liverpool as a third record, fourth record. Yes. Why? Because here the all the ages are same, but as per the given cities, so the chronological order of the cities are, Liverpool will come first, Liverpool is come first, and after that we will get London and London. So that's why I am trying to considering it as a fourth record. And remaining 2 records we are unable to decide which will come first. The reason is both are having same ages and as well as both are having same city names. So anything will be coming first, no problem at all. We need not to think about it. Now out of all the 4 options, try to read it. What is the first option? Jack Brown and Jane Brown appear at consecutive position in the result. No, Jack Brown, Jane Brown. In middle of these 2 persons, we have one more record is there, Jack Wright. So that first option is wrong. What about the second option? Thomas appears at the third last position in the record. Yes.
So Thomas is occurring in the third last position in the record. So the third last position in the sense from the last 1, 2, 3. Yes, in the third position Thomas Smith is available. So that second option is right option. What about the third option? Jack Smith appears at the last position in the result. So Jack Smith, it is highly impossible to decide whether the Jack Smith is occurring in the last record or Jane Smith is occurring in the last record. Why? Because both are having same age and same city name. So we are unable to decide that Jack Smith will be appear at the last position in the result. So that it is not at all correct option. What about the last option? People at last two positions have the same last name. Yes, definitely. So in the last two positions, we are unable to decide who will come first, but if you're going to consider the last names of the two persons, we are getting the same name, Smith only. So that's why the last option is also correct. Out of all the four options, the right options are second and fourth. Now let me try to go to the next question. So here the question is, we have one test table is there. So in the test table, A and B columns are available. Now what is the question? What is the output from the execution of the query provided below? What is that query? Select B as A. So we need to reverse the columns, okay? And here how to consider them? Sum of A as B. So we need to consider the sum of all the elements in the column A as B. That too from the available table test by using the group by B column. So in the B column, try to group all the elements. Totally three groups are there. What are the three groups? This is the first group. So what is the second group? The second group is this one. Let me try to take some other color. What about the third group? This is the second group, and coming to the third group is this is the third group. Now as per the groups, try to calculate the sum of A as B from the test table group by B. Now as per the first group, can you please observe? This is the first group. As per the first group, what is the sum of A? 3 plus 3, 6. That we need to consider as a B. That means in the B, the value will become 6. For that, the A value is group of B. What is the group of B? 1. Next, for the group 2, try to consider. For the group 2, the sum of A is, what is the sum of A? 2 plus 1, 3. We need to consider it as a B. For this group 2 in the B, we need to consider it as a. Next, group 3 in the B, for this we need to calculate the sum of A. 1 plus 2 you will get 3 and try to make it as group B value. And for this group B, we are getting 3. That related group B value we need to take it in the A. So 3 we need to take it in the A. This is the updated table we are getting after executing the below query. Now try to check it where it is available in all the four options. So I think it is available in the second option. So in the second option for A 1 2 3 we are getting B value 6 3 3. How we are getting? Very simple. So here the query group by B. As per the group by B, we need to calculate the sum of A for the group by B. For the first two elements in the group B 1 1, the sum of A is 3 plus 3 6. We need to take it as a B value. For the group B, in the group B second group, the A value summation is 2 plus 1 3. We need to take it as a group B value. And in the group B itself, the third group is 3 3. For this 3 3, the summation of A value is 1 plus 2 3. So we need to take it as a B value. For this 6, group number is 1. For the 3, group number is 2. For this 3, group number is 3. We need to take them as A values. The right option is second option among all the available options. That's all. With this, I hope you got the complete idea regarding all these questions. Thank you, Ananda.